Je 9:15, myslím, že môžeme začať. Moje meno je Filip Pohronský. Ja by som vám dnes na úvod chcel povedať zo pár veselých slov ku Kubernetes svete, ku tomu, ako som sa trošku k tomu dostal a najmä na ten úvod vás trošku zaujať nejakým tým smiechom. Som dosť starý na to, aby som si prešiel mnohými rokmi vývoja v IT a to, čo bolo včera ešte funkčné a platné a trendy, sa zrazu ukázalo ako niečo zastarané, lebo niekto prišiel s niečím novým. A úplne bežne sa to stáva vo všetkých oblastiach, špeciálne v IT, v ktorej pracujem, je ten vývoj veľmi rýchly. Pamätám si, keď som rozbiehal svoj operačný systém na bare metali a na to som nainštaloval nejakú aplikáciu. Skvelé, neskôr človek prichádzal ku väčšej a väčšej komplexnosti až k záveru tých vrstiev, ktoré pribúdali na tom bare metali, bolo toľko, že človek musel začať sledovať, čo sa vlastne deje, ktorej vrstve. Na začiatku sme mali trojvrstvovú architektúru, ako som spomenul. Dnes príchodom Kubernetes tých vrstiev je veľa. Ale v podstate stále tie tri vrstvy sú tam, akurát nám treba pribudli rôzne veci, ktoré sa týkajú network, function, virtualizácie a podobne. Čiže ten stack tých jednotlivých vrstiev je ďaleko väčší a prináša ďaleko väčšiu komplexnosť, ale zase zjednocuje ten pohľad na tú sieť. Keď som začínal, samozrejme, každá knižka hovorí o tom, že máme mať vysokú úroveň dostupnosti, takže dve vetvy, vetva A, vetva B. To sa však stalo byť zastaralým, prišiel nám Trill ako protokol a ten povedal, bude fabrika, zbavíme sa spanning tree protokolu, bude to skvelé. Neskôr som si všimol, že vendory začali ukazovať svoje aplikácie, kde potrebujeme tri appliances, tri hardwareové appliances. Hovorím si, dobre, však svet high availability, N+1, prečo N+2? A začal som pátrať, čo sa vlastne stalo a došiel som do štádia, kedy som pochopil, že je tu niečo nové, niečo, čo potrebuje 3 mástre a je to veľmi obľúbené medzi korporátmi a je to niečo trendy. Tak som začal hĺbšie a hĺbšie kopať a zistil som, že tieto vrstvy všetky dávajú zmysel a aj samotné použitie troch appliancí takisto. Začal som študovať, učiť sa asi ako všetci z vás, čítať knižky, skúšať, baviť sa na tom, že niekto dokáže v 5 minútach vysvetliť takto niečo komplexné. A tak som sa chcel stať Kubernetes administrátorom, certifikovaným. Lenže uvedomiť si, že riadiť stíhačku v produkcii bez znalostí z praxe bude docela náročné. A preto oceňujem aj vás, ktorí ste tu a ktorí máte skúsenosti z praxe, že naozaj nie je to niekedy jednoduché. A tak evolúcia ide ďalej. Myslím si, že máme pred sebou ešte veľa nových zážitkov. Naposledy prichádza umelá inteligencia, ktorá nám opäť sa zasahuje do všetkých častí nášho života. A ja som len zvedavý, čo príde do budúcna. Stávajú sa aj veci, kedy sa pozrieme späť a niektoré firmy sa vracajú k monolitu. A to ma veľmi pobavilo, pretože človek vidí, ako sa veci vyvíjajú a vracajú späť, keď to naozaj má ten zmysel, tú technológiu vrátiť späť do niečoho, čo bolo lepšie, úžasnejšie a použiteľnejšie. Chcem vás privítať na tomto druhom dni konferencie. Dúfam, že si spolu užijeme tieto chvíle, plné prednášok, workshopov. Z posledného dňa by som rád pripomenul príspevky Emanuely Zákone, ktorá nám rozprávala o Prometee od začiatku až vlastne po to použitie, o tom, ako je ten Prometheus nasaditeľný, ako je obľúbený, ako sa dá veľmi rýchlo inštalovať a používať. Mali sme príspevky od ľudí ktorí nám hovorili o tom, ako budovať škálovateľné software ako služby. Ondrej Šika je veľmi dobrý speaker, veľmi dobrý učiteľ. Vie vás prejsť od tých základov až po vie s vami prejsť tú cestu od tých základov až po vybudovanie a prevádzku klástra. Treba poďakovať partnerom F5, ktorí tu tiež prispeli, nie len svojim partnerstvom, ale aj prednáškami a workshopmi. Treba poďakovať Pure Storage, ktorí takisto prispeli svojimi prednáškami. A myslím, že aj včera, tak aj dnes, a aj zajtra budeme mať veľmi silný zážitok z tohto prostredia, z nových kontaktov, z komunity, ktorá tu je a ktorá si aj v sobotu našla čas. Treba pripomenúť workshopy, ktoré sa udiali. Vidos mal svoj vlastný workshop ako jeden z partnerov. Raymond de Jong hovoril o Cilium a samozrejme silná téma Argo CD zaznela od Milana Skúhra. Rád by som vám pripomenul dnešný sociálny event, čiže spoločenskú udalosť, ktorá bude o 18. hodine. Informácie k tejto udalosti nájdete u organizátorov, čiže všetci tí, čo majú fialové trička, tak u nich treba sa pýtať. Sme otvorení, dostanete od nás pásik na ruku a inštrukcie, kde sa nachádza sociálny event. Veľmi radi vás uvítame, začína o 18. Takisto treba pripomenúť workshopy, začínajú o 9:30, hneď vlastne po mojom talku. Zoznam workshopov je dostupný aj na slajde. Musím vám pripomenúť, že v nedeľu bude tombola, aby ste vedeli po 16. hodine a je len pre tých ľudí, ktorí tu budú zúčastnení na mieste, aby sme dary alebo teda výhry mohli rozdať medzi ľudí. Prosím, používajte Slido na otázky. Takisto vlastne máme aj stream do YouTube kanála, čiže audiencia je aj mimo týchto miestností. Prosím, odpovedajte na Slido ankety. Veľmi radi oceníme, aj ten speaker ocení, nech vie, ako je na tom so svojím príspevkom. Popozerajte sa, prosím, okolo sponzorov a najmä, treba povedať, k tomu sociálnemu eventu. Tie pásiky získate aj od sponzorov. Keď si ich vypýtate, sponzori majú zásobu, veľmi radi vám odovzdajú takýto pásik. A tiežme sa spolu, zabávajme sa a niečo nové sa naučme. Toto sú ceny, ktoré boli venované našimi sponzormi do tomboly. A chcem poďakovať týmu organizátorov, ktorým patrí veľký potlesk, že sme sa tu vôbec mohli zísť počas tejto trojdňovej konferencie. Hlavným partnerom a partnerom za to, že nám umožnili, že tá konferencia sa mohla uskutočniť a poďakovať vám, že ste si našli tú chvíľu času a strávili ju so mnou pri úvodnom slove. Veľmi pekne vám ďakujem. Teraz je 5-minútová prestávka a 9:30 začíname s prvým príspevkom v tejto miestnosti.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
stealthier,
engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
congratulations! Oh my God!
Each other.
For our neighbors.
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
Titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
what security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Stále máme minútu teoreticky.
Teoreticky. Ty máš pravdu, taký flexibilný je ten čas. Skúsený DevOps architekt. To je pekné. Lebo vieš, ak sa hovorí o skúsenosti, ľudia prichádzajú s skúsenostiami.
Good decisions are a result of the experience. And experience comes from a bad decision.
Hej, to je krásne. To si zapamätám. No, použijem vo svojej nedeľnej kázni.
OK, go ahead.
Takže ja by som privítal Mira. Je to skúsený DevOps architekt a prišiel sa s nami podeliť do svojej skúsenosti, ktoré nadobudol počas svojej IT kariéry. Takže Miro, stage je tvoj.
Will be doing this in English because it's kind of easier for me to speak English when I talk about technical things. So my theme is the technical debt and the cloud infrastructure, or you can do just one thing. So the agenda is, I will be talking about technical debt, about its causes, symptoms, and what people tried to fix it, and specifically how this works inside the area of the cloud infrastructure as a code. And I will also mention some path of mitigation, some of which worked for us, and some of which were kind of not so successful. First, a little bit about my bias. I'm talking about me not because I think I'm important, but because if somebody tells you something, it is always good to know something about that person. What is his or her experience? What is the bias? Therefore, whatever is being said can be interpreted in certain contexts. I've been doing these IT things for over 30 years. I started as I'm on the my school is. This school, actually, or the school that was before this school. I started as a sysadmin, then worked as a developer for quite a few years, architect, SRE, and finally DevOps. In the last year, I started coding in C in late 80s, then Perl, C++, Java, C#, Python, and these days mostly Terraform, CloudFormation, and CDK. I work with the cloud from 2015, which is something like 8 years now. And the area I worked in is an enterprise level e-commerce. That is the e-commerce solution for a big systems based on a big frameworks, and Oracle Commerce and SAP Hybris. I lived on the both sides of the DevOps divide. I was developer and operations person, so I kind of know how the thing looks like when you are looking from this side or from that side. That means that we built and deployed e-commerce site, big e-commerce site. We released it, maintained it, supported it, monitored it, enhanced it, and essentially did it all over again. After 25 years living abroad, I'm back in Bratislava since the last 2 years, and I currently work as a cloud infrastructure in a cloud infrastructure team for a Canadian company that opened up conveniently an office in Spain, which is where I'm employed. What we do build cloud infrastructure, mostly in Terraform, and we also maintain over 100 AWS accounts for our customers, and they are running production workloads in these accounts. So our group is responsible for monitoring, troubleshooting, CI/CD of several of these applications. So this is about the bias. This is why I may sound a little bit not overly optimistic. So what is technical debt? Technical debt is defined as additional cost of changing or maintaining the software. So whenever you build something and later on you need to make a change in this software, you will find out that before you do something, you need to do something else. This is why the topic of my speech is you cannot do just one thing. Because the debt is almost always present in some form. So instead of adding features that you wanted to add, you work on fixing legacy bugs. You have to rework some decisions that turns out not to be optimal. It is quite often compared with a financial debt. It is like if you have a certain amount of money, you want to do something or build something. Instead of doing what you intended to do, you need to pay interest on a debt that you incurred in the past. Now, unlike the money, the technical debt is much harder to predict and quantify. It is not obvious at all when you start how much is there to do. So this is where, so in a financial situation, you usually know exactly how much you are going to pay for the interest, for your loan or for the debt. There are many causes of a technical debt. Some of them are good or considered good, and this is the conscious trade-off when you are building a product and you don't want to do, you essentially want to build a minimum viable product. You want to release it quick, find out how it works, and so on. So we made some decisions that you cut corners, you don't implement certain things, and it's in order to gain the speed. So this is the good cause of the technical debt. This is happens mostly in a product companies. It has a fine print, it has a consequences which say that essentially even the good intentions can lead to a consequences that are not so good, but that's one of the good reasons of a technical debt. So this is something that you knew you are doing, you decided to do so, and you were fine with that. In real life, there are often other causes of technical debt, and the first one is the time or budget pressure. You simply don't have enough time, the deadline is too close, or you don't have enough budget to do everything that the perfect product would require. So you do your best, and you leave some debt behind. And sometimes your requirements change late, and suddenly the decisions that you made based on the previous requirements are not the best decisions now. Quite often developers change, new developers come to the project, and the new developers don't have the same mental picture, same mental model as the old developers, and make some coding decisions that are contributing to the technical debt. If your project lacks of code quality tools or QA processes, it can also lead to a code that is not optimal and has some debt. Also lack of knowledge on design and development side, or a lack of collaboration. So if you are having a distributed team and you don't communicate properly, you may end up with multiple implementations of the same thing, doing differently. So therefore, if you need to do that, redo that area of functionality, you are doing it twice or 3 times, depending on how many re-implementations you gathered. Quite bad can be when there is a lack of development leadership, there is not a strong team lead and strong architect, and developers simply pick their favorite tools and frameworks, and you end up with a project that has 15 different libraries in 4 different languages, and maintenance of such a product is much harder and much more costly, because you need a skill set that is much harder to get than if your project would be a little bit more streamlined. And then there is this hurry up and wait management style, that the decisions on the business stakeholders are taking forever, and the deadline doesn't move, and development team cannot move because it hasn't been approved yet, it hasn't been decided yet, and then suddenly you have much shorter time to implement things that you originally planned for. So that's the real life causes of the technical debt. The consequences are obviously missed deadlines, cost overrun. So because for each change that you want to do, then you need to do something else first, and that something else can lead to a different something else. Sad results of that is that often, in order to make the deadline, the teams postpone the actions and activities that are important for fighting the technical debt, such as documentation, tests, or code analysis. And it leads to a kind of a vicious cycle that the code base gets worse and worse. And if you don't apply some counter force, you will end up with a code base that has very high debt. When you try to quantify technical debt, it is important to realize that what is the standard you are comparing against, because there are 2 cases that I would like to introduce here. There is case one is you are building a sales demo or a proof of concept, and your intention is, I will build it, I will show the customer, we will validate the design, and we will then throw it away and re-implement it properly with everything that the project needs to have. And the second case is a production level project, it's a SaaS system that must have proper security, monitoring, documentation processes, and so on. So if your POC quality is being measured against the production standard, you are wasting money, because you are implementing things that will never materialize. If your POC is really throwaway code, it doesn't really matter if it's debt-free or not, because it is not going to live forever. Nobody is going to work on it. However, if you do the opposite, if you build your product, your kind of production level code base using the standards that are good for POC, you will have something that is very hard to maintain. Therefore, it is important to understand what are you comparing about, what are you measuring about the debt. And sometimes it kind of automagically happens that your POC transforms into the production code. I've seen it happening in the past when the The sales made presentation, customer was excited, was absolutely ecstatic, when can I have it? And the sales made promise, and you end up with something that was meant to be not to be used in production, to be used in production, and then development team started to retrofit, re-implement parts of that should have been there from the get-go. It cost more and takes longer doing it that way, trust me. There are many types of technical debt. The most classical one is the development debt, development quality debt, when developers are simply not doing everything that should be done, cutting corners, overlook. The worse than development quality are usually decision debt, when you make decision based on some short-term goals that turns out not to be valid in the long term. Therefore, the long-term consequences of the short-term decisions are not good. And it has implied effect on scalability, stability, and security. Then quite often we see the maintenance debt, that is the data accumulates and suddenly system breaks because nobody was really testing it with the amount. I once saw at a customer 15 years ago that had this brilliant idea of collecting unauthenticated sessions and persisting them into database. So the idea was that based on the cookies, when the customer comes back, they will have their shopping cart, which is a brilliant idea. But if you don't implement something that cleans up this abandoned session, you will end up with like 800 million records in an Oracle database, and it was in 2003 or 2004. And at the time, having that amount of record in a data center database was not an easy thing to fix. Deleting these records took days. So there are also vulnerabilities in libraries that you use third-party libraries. These libraries have vulnerabilities, and if you don't keep up with it, if you don't maintain and fix the libraries, replace the libraries, you will end up with something that will eventually, you will have to do it in the moment when you need to add a new feature. So instead of adding new feature, you are working on upgrading the libraries, and the upgrading libraries can lead to upgrading other libraries. So this is kind of the nice snowball. So we will end up working on upgrades instead of doing what you originally intended to do. Now we are getting slowly into the infrastructure and the cloud areas. There is this debt that I call a platform speed debt. And essentially, you're building on a platform, for example, AWS, and the platform is evolving. It's evolving very, very fast, and that evolution forces you to change things. So you have your product that works fine, or your code base is stable and you can do everything is okay, then you need to implement some add-on feature or change something, and then you suddenly find yourself, I need to upgrade this because Kubernetes EKS is already out of support. You need to upgrade that because you are using the old version of Helm or Terraform the speed of the platform, speed of the ecosystem is forcing you to essentially creates a debt for you without you doing anything wrong or without not following the best practices. Often when you are building a product, when you're adding new features, this causes issue that you did not anticipate. For example, you hit the design of the data model or some unexpected consequences of your decision. And if you are a system integrator that works with the vendors, there is this very special situation, which is I call it SI tax, system integrator tax. It's valid for the service companies that are implementing using the big framework. So it goes like that. You work with the platform vendors, I will not use any names, and you are selling a solution that is based on some platform. You are a system integrator, you will customize it, you will implement the business features based on that framework. You go to the customer selects both platform and the system integrator. You are co-selling. You go there and the customer I need these features, and vendor says, oh, it's out of the box. Yes. It's absolutely, our system can do that. And you as a system integrator know that it is not quite so. It is that the feature is there, but will not work for the customer and will require some customization. But you cannot really say anything because you want to make the sale if you are tied to that vendor. and you need to make the sale together. Therefore, you kind of accept that, okay, if we win this, we will have to re-implement or enhance this, and customer assumes it is not going to cost them anything extra because it is already out of the box. So this is this kind of special tax that you accepted when you decided for any particular framework for this thing. So I've seen that happening quite a few times. How do you eliminate technical debt? So it usually starts with assessment, and depending on the result, there are multiple paths ahead. So first path is kind of deprecated. If the cost to fix is so high that it's comparable to writing it from the scratch, then usually you are better off writing it from the scratch, because you will starting from a more current, more recent starting point. And developers are especially happy to start rewriting stuff, because what the old team wrote is never good enough, and we can always do better. We know that. But there was, if you know Joel Spolsky, he's the guy that gave us Stack Overflow, among others. So that's he's pretty big celebrity in the industry. He wrote back in 2000 or 2002, sometimes long time ago, a blog post warning against rewrite, and was using the example of a Netscape as a warning sign. And read that blog post, find Joel Spolsky and rewrite. It is easy to find. It is a very nice cautionary tale that tells you that not always the total rewrite is such a great idea and such a smooth thing to do, but often it is the right decision. So then you have 3 R's: refactoring, replatforming, and re-architecting. So refactoring is essentially taking your code base and changing pieces of it, replacing it with a better code without impacting the resulting functionality. So from the user perspective, system doesn't have any new features. It is still the same functionality, but internals are better. You usually work on better configurability, better logging, removing bad code, adding some documentation, some tests, some automation. And this is a great idea, and this is the right approach how to fight technical debt. The only problem with it is pretty hard to sell. So you are going as a development team spending I don't know how many weeks working while somebody pays for that time, and you are essentially not doing anything. And the esoteric argument that you are improving the quality of the code, well, the customer doesn't really care about that. They need a business functionality. The second one is the same thing as refactoring, only like from the platform point of view. You re-platform. So often when your application hits the limits, then the solution is to use the brute force, lift and shift, and move it to the cloud. That often happens in the data center, where using the brute force and using big EC2s and big databases and SAS databases and RDS and the other beautiful things that cloud gives us, it essentially gives the application ability to overcome those limitations that was experiencing. So. And the third option, this is the best one, but very hard to sell because it's the most costly one, is the re-architect. It gives you most options. It gives you ability to carve out pieces and replace them with the native cloud services. It essentially makes the application modern, makes the application cloud native. This is something that we always like to do, if possible, if we have opportunity. There is one catch. There is this shiny new toy. Sometimes when you do that and re-architect the application, you will end up something that is much more complex, requires much more resources, and much bigger team to maintain and monitor than the original things that was running in the data center. Again, I've seen that happen. So what is now different for the technical debt in infrastructure and cloud space? The first of all is a frequency of builds. So unlike the developers, we don't build infrastructure several times a week or daily. The infrastructure is built and stays built. Therefore, the new environments are usually released as part of the projects, not as part of the kind of the daily life of the project. So if the frequency of the builds is low, the chances of discovering technical debt on the next build is significantly higher. Also, the platform speed is very high, which also increases the probability of discovering that you need to do something else. You cannot do just one thing when you are building the next version of the infrastructure, because you need a new environment, or there are some new resources required in that environment. Also, tools evolve very fast. There are security patches coming at you all the time that you need to incorporate, and you have absolutely no control over these tools or platform. Amazon will do what Amazon wants, and the HashiCorp will do what HashiCorp wants, and you have to live with whatever they deliver. So the lifetime of builds is usually years without replacement, or a kind of many months. It is not like this application is being deployed and that version of the application lives, I don't know, weeks, maybe months. That's at the best. So what you build is there to stay. For example, this is the EKS evolution. Just watch the versions in the left column, watch when it was released and when it's the end of support. You see that your platform jumps every kind of couple of months. So if you build something in 2 years ago, in 1.19, it is being a long time out of support, and you need to upgrade it at least to 1.23, which will end up in October, in order to gain some time. If you want to plan ahead, you need to upgrade at least to 1.25, 1.26. And a very similar thing is for the Terraform, which is the Terraform evolves a lot, and it is a little bit more stable these days, but there were a day when they were making breaking changes. So if you had an old code base written in Terraform that was working perfectly fine, and you did not use the old version of Terraform tools to build it, you had to modify your source code. Also, what is different about infrastructure and cloud is that our testing is significantly harder and more expensive. So it is not like you run unit test, integration test as for the application. You actually need to build the application, and build the infrastructure, and building infrastructure and running it costs money. So your test is something that is not as easy to do or as cheap to do as the test for the application code. You have a cost of execution, the test, and also the cost to run. And the final test of any infrastructure is to deploy the application and see if it runs on that infrastructure, so which adds even more time. Then this is this state things, or state of the state. So when you build infrastructure, you store state of the infrastructure somewhere in the Terraform cloud or in the S3 bucket, or if you are crazy, then on your local machine. Then this state is often changed when the new version of Terraform comes, and if you have an old enough build, you may end up and use the latest version of Terraform. You may end up finding out on the next build that the internal format of that state changed, and whatever you have stored is not valid anymore, and you need somehow to migrate it, or in the worst case, you will download a 30 meg JSON file, which is the Terraform state, and you will start your Vim or whatever editor you use, and you will start to change stuff in that file and to make it work again with the latest versions of the tools. That's not something that you want to do. So avoiding that should be fairly high on your priority list. Also, speaking of state, we have this thing called drift, which is, again, doesn't happen for the application code, because nobody is going to go inside the binaries of your application and change something there. But it is very, very well possible that somebody logs on into AWS console and your perfectly GitOps ready infrastructure as a code infrastructure is being modified by somebody that has permissions or doesn't know any better. And that person, if that person doesn't translate those changes back to the source code, you will end up with a drift. So the state that is actually running in the cloud, the state that the Terraform thing is running in the cloud are not the same. And you have additional tasks to do to reconcile the drift and fix that, either import the real state or make sure that whatever was changed manually in that environment is fixed. We have less advanced languages as the developers do. We have YAML or the HCL, which is not on par with a Python or TypeScript or Java or whatever languages you use. Yes, you can use CDK or Pulumi that allows you to write the infrastructure code in the higher language, like Python, for example, my favorite. And that they generate something like CloudFormation for you, but to debug, when something doesn't quite work in the translation, you will usually end up with a problem of debugging these things, which is not always so easy. So there is a trade-off. So, and also we have very complex ecosystem and very complex dependencies, and sometimes these dependencies are causing issues. Path to some mitigation. So first of all, what worked for us is manage expectation, plan maintenance and upgrades upfront. That means make sure that every stakeholder understands that when we build this infrastructure, there is an effort that needs to be invested in order to keep this up to date, and especially for if your customer is the first time cloud projects, they kind of assume, oh, you build the infrastructure as we did in data center, and it will be good for 4 years now, and everything will be fine. It's not so, especially not if you are using cloud native systems. You should use standard proactive measures like a quality tools, unit test, integration test. And what worked for us is kind of maintaining 2 branches of infrastructure code. One is the main one, which has the current deployed status and is version locked. That means that if you run it again, because it's version locked on the library version, on the tools version, it will build. So you can always build properly. And to have a other branch, call it latest, or that is the bleeding edge that is not version built, and you essentially, when you run it, it will get everything the latest out of what is released, and will try to build infrastructure using the latest state. And you will see whether that build succeeded or not, and you will see that when you try to do that as a part of some upgrade or deadline or something, that whether you will succeed or whether you will have to do something else before. Then it is a good idea to schedule regular fire drills. That means regular builds of both branches. Just do it. And if you can do it monthly or bi-monthly, but don't do it like once or twice a year, because as you see in those slides, this is not, the speed of the cloud is much faster than that. So you will know if everything is still okay, you will know if you can do the next hotfix, and you will know what lies ahead when you will try to build a new environment with the latest tools. It is also a great idea to monitor used open source libraries, because open source is both blessing and a curse. Because it's a blessing because there is something that is publicly available and it solves a lot of problems for you. But it's also a curse because you essentially don't control the direction. So if the project goes in the direction that doesn't suit you, you have 2 options. You either follow the direction or you try to create your private copy of the project, but then you lose the advantages of the things, because you will not, even if you make it properly as an open source, you will not find anywhere comparable amount of contributors as the main project. And it is not very popular decision to create your own version of something that is being used by many people. So don't create those forks haphazardly. So it is usually better to have 90% and open source than have 100% perfect for you and be responsible for maintaining it. And if you already do create your private copy, by all means, please make sure that your versioning and their versioning are compatible, because the worst things to reconcile is if you have a private version of some public module and your versioning is not following their versioning, then it is confusing like hell to put the things back together if you need to take upstream changes and integrate into your private repo. Also, consider reusability advantages and disadvantages. People universally believe that reusability is always good. That means you always should extract shared code and have a library and so. But if you do that and you touch that library, you should and you want to avoid any future surprises in the form of technical debt, then you should test that library with all the clients that use it. If you don't, you may have to do other things before you do that things that you wanted to do. So documentation is a key success factor. We work as remote teams, distributed teams, and good documentation can save you a lot of headache in the future. There is this link that I use. There is a nice blog post about the types of documentation and how you should structure documentation. We introduced it a couple of like a year ago and so, and it worked really well for us. You have to realize that test code is both asset and responsibility. That means it's good to have test code because it's really useful, but the more test code you have, the more test code you have to maintain, and test code can also incur technical debt. So your tests break because something in the test framework changed. And now you need to fix the test code in order to execute the tests first. Use automation, well, that's pretty obvious. Your build pipelines should be automated. You should be you should code everything that is being executed repeatedly should be scripted, but you are creating more code, which can contain technical debt. So keep that in mind when planning. And GitOps is usually a good thing, and everything becomes a code. The hard part about GitOps is to make sure that that is the only way, because if there is a backdoor to the system in the cloud that it can be modified without the GitOps, then you will usually need to pay the price. So I'm pretty much out of time. I prepared a kind of a real-time, lifetime story with something that looked like I will do it in a couple of hours or so. There was this upgrading version of framework from Java 11 to Java 17. And there was a new phase of the project. We revived environment that was built in 19 and 20, and there was no budget for maintenance it while the project was idle, so nobody touched it, EKS 119. And after our build was Dockerized using multi-stage build, so everything was fine on the build side, and once we deployed the Docker images, we found out that the Sonar fails. Well, the Sonar fails because the Sonar didn't recognize the class format of Java 17. So we said, okay, we will upgrade Java in Sonar. But then I found out that Java in Sonar cannot be upgraded so easily because it's tied to the version of the server, and instead of Sonar 8.4, I have to install 9.8. And the Sonar 9.8 used a different Helm chart because the Helm chart we used when we installed was deprecated. And the Helm chart that we wanted to use required Kubernetes at least 124. So within like 2 or 3 hours, I got from things I'm going to replace, change the Docker build, to something that I need to do EKS upgrade. So then I started to do the EKS upgrade. I found out that the Terraform code is old, and Terraform, it has some issues that I need to fix first, and the modules that we use when we build the environment hasn't been really evolving with everything else. So it essentially what looked like that'd be a very quick fix, and it took a couple of days to resolve. We ended up with 2 clusters, one just to compare the functionality. We had different set of issues, and then I, out of kind of desperation, tried to install ignore the recommendation of the class of the EKS version and install the Helm that required 123 into the old cluster, and guess what? It worked. So, so the lessons learned: don't let environment, even the development one, sit for 2 years without being properly maintained. Otherwise, you will accumulate some debt. And don't trust the documentation, try it out. And reuse is sometimes overrated because all those modules that we had to upgrade were in the end they were more trouble than the actual benefit. Sorry. Okay. Do we have any questions?
The questions for you. What you can recommend with the versions of Terraform modules, strictly pin in infrastructure as a code, or deal with unpredictable applies?
Actually, I recommend both. I recommend these two branches that have kind of one is tied to version that certainly work, so that you can always run it, and then have the latest and run it regularly, so that you will see there is not a one right answer. If you don't upgrade, you will end up with something that accumulates technical debt. If you don't lock the version, you have unpredictability and you accumulate the technical debt. So you need to actually do both if you really want to be. That's the price for the speed of the platform.
So next is React detecting in the way it consumes more resources and complexity acceptable if it brings more benefits to business?
Well, it is always a business decision, not a technical decision. In my experience, I've never seen one case when the engineers had a final say when it came to these things, but generally, re-architecting, if you can convince the stakeholders that the re-architecting will allow them to go into the territory they wouldn't get otherwise, that you may be successful. For example, if you re-architect something to cloud native and the elasticity of the Amazon will allow them to scale up within few minutes, it can be a critical component for the Black Friday. It is very hard to do the same thing inside a data center or without those cloud native things like autoscaler in Kubernetes and so.
So I think we have time for one more question. Is tool TF Autom acceptable in a case of eliminating tech debt with Terraform?
I don't know. I would have to figure it out.
Thank you, Miro. Thank you so much for your presentation. Let's have a break, and we will start at 10:10.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations. Oh my God,
Each other.
For our neighbors,
our kids,
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Hello. Okay, so our next talk is Adam Skotnicky with a presentation titled Tycoon DevOps at Your Service. I will leave it up to you to introduce yourself.
Thank you. Hi, everyone. I will be following up on the presentation previous a little bit. That was about technical depth, and I will be talking about this from the people perspective a little bit, and how to replace some processes which could be automated with some other tooling, right? So it's never-ending story. So a little bit about me, to give you context what I'm talking about, and that I know at least a little bit about what I'm talking about. I work with Kubernetes and in Kubernetes community for a really long time. This funky picture is from 2016 in the first KubeCon in London. Not first KubeCon globally, that was one before in US, so this was first one in EU. And at that time we already, with Kuba, we had presentation about how we use Kubernetes for smart cities, right? So two buzzwords together at the time. And my background is from data centers and private cloud. I started in 2010. In 2012, we started a company called TCP Cloud. We were building private clouds for enterprise companies, telcos, banks, and so on. We got bought by US company, and then we built even bigger clouds, right? So 6,000 nodes and so on. So this is my background a little bit in private clouds, public clouds, and tech, and with Kubernetes. By the way, that time, I was really interested in time in Kubernetes because it was pure cloud native tool that time, which is not so much anymore. It's a really complex tooling now. But that time that you didn't even have stateful sets, right? That time you had something called pet sets, like they were really new. And that was basically, they name, or community name it pet sets just to mock people request to have static domains. So you can have all the time same domain name when the potter starts, because that was not the rule before. So that was really interesting time in Kubernetes. What I want to be, but this is not what I want to talk about. So what I want to talk about is this. I call it the table. And what you see here, it's just average DevOps salary across seniority in average EU salary. So it can, of course, it can be different country to country, but this is EU average. By the way, the year salary is what I used, the month, and salary day is calculated based on how many days, in fact, you can work, including your vacations and so on. So the salary day is, in fact, calculated a little bit. So what is important, what I want to say is that a lot of people focusing on one aspect of DevOps or tech, and that's what tooling you use and how to do it technically, and really often they forget about the cost of what they're doing. So the technical debt is really, really interesting one, because technical debt is really connected with people and how people reacted on the management layer, and but also on the technical layer. One of the things is that often people do decisions based on internal opinion. Management layer is usually not, management people, it's not directly connected and with the technical people. They do not deeply understand the impact, what is their decision in the end. So really often you see, and especially in a little bit bigger companies, that DevOps teams decided that they will do everything on their own. And that's basically what is the technical debt is started. Because when you start hacking Kubernetes, for example, you will decide that, okay, I will write my CRD, I will write my operator for something, or I will use the open source project, but I will change a little bit something somewhere because I am better than that. That's basically the where disaster in future will start, because you starting creating two things. First, you have unique solution. Second is depending on you, right? So this is from people perspective what mostly DevOps people doesn't see at all, that you also have a cost. You are not you should be replaceable, and what you're doing, it's not about your know-how, but the value of whole solution you will provide in the end. And doesn't matter, in fact, if it's public or private cloud, or in fact what technologies you're using, it's not tied directly to Kubernetes. But Kubernetes is big culprit, because Kubernetes is big platform and will allow you to do a lot of things. So what you can do about this, right? So first is to even realize that there is this aspect of what you're doing, that you should be part of solution which is long-standing, which is repeatable, which should be automated as much as possible, and it's not reliant on you. Some people like it, right? So they like to be the boss, or they like the feeling that everything's depending on them in secret and called in the night to fix stuff and so on, but that shouldn't be the goal. Goal should be that you are on the side, you are not the origin of the solution, you are managing the solution. That's I guess, the DevOps ultimate goal, to provide stable environment where application can run, because the ultimate value of what you're doing is that something will run on top of infrastructure, and it could be database, could be internal application, could be WordPress, could be scaled from single instance to millions of instances, doesn't matter, but DevOps goal is to run things, not to hack things. Most people like to hack because more senior you are, bigger chance is that you will create something custom, right? Because you already have the experience, you have the know-how, you will build something which is unique. And because you have, like 10 years ago, you gained some know-how and you built on that, you still have the know-how. So I still hear questions regarding, can I run database stateful applications on Kubernetes, right? And then this is my, that's why I used the slides from 2016, because then we had same questions, right? But they were answered with the pet sets back then. And of course, there's more questions to that, but it's like really old question. And it's still here because someone get the know-how about, yeah, you cannot run database on Kubernetes that time, and they're still keeping it. So, and that's why also when you are in public cloud or any provider, they're pushing you forward because they're doing this for you, right? Because they're doing it for everyone. So you have centralized solution which moves, and you are forced to move too. Sometimes it's called bleeding edge, or sometimes it's just the way how to operate IT, but you need some tooling for it. And what I've seen in the past 10, 12 years regarding to private cloud builds, and small, big, doesn't matter the scale, there was still same issue. Every time same issue occurs. When you build something in the beginning, it usually stays in place and as is for a long time until someone came after 5 years and will do the re-architecture piece, because there's no other way to do it, right? So, and that's not the optimal thing. Usually best, at least in theory, best thing is to keep stuff somehow independent on you and moving forward, and you just, keeping the distance and keeping stuff running. And for that, we created a tool to do it, which is called Tycoon. It's just really, really brief product pitch from my side. That's what we realized, and we built a team and company who is trying to flatten the DevOps layer, right? So flatten the amount of decision you can do, and it's connecting also two things together, and that's management and technical people together. So it's not just, in fact, about what version Kubernetes I will be running, or what security, OPA policies are applied. It's also about self-service. Enable people to don't write you email when they want something to change, but you should be able to enable them to change somehow in their environment. So that's what we do. But in fact, we will have workshop about this in 13:30 in workshop 2 room, and then we will have more time to show you and prove. And also 2 angles of it. Something yesterday someone called ClickOps, which is really good reference. So you see there was a dashboard, right? Clicking things. That's not how it should be. It should be automated. And of course, UI is there for beginners or for people who like to start, are coming to Kubernetes from other sides, from developers, for example, and they just want to have cluster running. But in fact, the ultimate goal again is to be independent. So integrate, automate, do the GitOps way. In our case, what we enable is to basically create the whole environment at the moment you need it. So it's not there. It's not like 2 things, that you're running environment, you have your Kubernetes somewhere which you keep in alive for years. It should be in a way that you are able to, redeploy it often, right? So you can just remove it, create it again, move the workload from side to side. It shouldn't be so difficult, in fact, with today's tools. It's just about how to use them. So that's why we try this, to eliminate the layer. When us in 2016, my know-how started with Kubernetes at the moment where you need to build your own etcd cluster separately to run Kubernetes, right? So that's not needed anymore and shouldn't be needed anymore. You shouldn't hack your own etcd cluster. Everybody knows that. But this will move forward, right? So now we should be in stage where Kubernetes as a whole shouldn't be cared for. It should be just service somewhere. And, everybody is CNCF. We are also part of CNCF. We are a silver member. We certified every Kubernetes version we do. This is just to say that you can run anything you want, and it should work between EKS and AKS and public and private, and doesn't matter. And that should enable us to don't care about Kubernetes. That should be, in fact, the ultimate goal of tooling now. Don't care about Kubernetes. Just don't solve the issues of Kubernetes. Because there is a story, right? So I saw It's one of the biggest e-shop in Czech Republic. There was LinkedIn post, and where someone from our engineering team announced that how happy they are that they fix as a first team globally Microsoft SQL bug when they scaled Microsoft SQL to, I don't know, 1,000 cores or something like that, right? So maybe they found this bug first because nobody used MS SQL on 1,000 cores or something like that. That could be the culprit, because sometimes you shouldn't push, you shouldn't push for something which is like unique or edge. Best thing how to use these tools is that if you spend 1 week and they work, that's good thing. When you spend 3 months on it and they work, you spend, 3 months on something with the cost of you on something which somebody maybe already did, and maybe you don't using the right tool anyway. So that's the question you should ask yourself. Anytime when you start something new, I'm able in 1 week to make it work somehow reliably, and then maybe tune a little bit, some alerts or something. Or I don't need. Do I know enough that I can run it or not, right? So because when you're hacking something really deep and for a long time, you make it unique again, because you will introduce your own bias into it. That's what we do inside Tycoon too. Are we able to use, we would like to get rid of Elasticsearch, right? Why? Because it's Java and consumes lots of memory, so what's the replacement? So we use something else, didn't work in a week, then we try timescale, worked in the week, so we use it. Then it didn't work again, so we just, segment it. We didn't hack it for performance, we just internally in our code say, okay, this tables will be running in this segment, and this will be in this segment. And we spent, I don't know, a few hours on it, and it can scale to thousands, or like in this case, millions of records without big issues, right? So that's what we want to talk about workshop. By the way, on workshop, we will be talking about 2 things in reality. First, it will start with the clicking. We will just click stuff. Then we will switch to GitOps. And then during the meantime, individually, we will discuss with you, use cases, where it could be used, where not. So you have some idea how do not care for Kubernetes, right? How do not care for basic infrastructure you want to run, and why you shouldn't. And that's my presentation. In fact, it's really short, so we can have coffee, after yesterday's beer. And maybe if you are interested in more, we can discuss, on the whole, some real use cases or some stories which I cannot say on record, right? And we can discuss this in detail. Thank you, guys.
Thank you very much for an interesting presentation and for giving us some time back that I took, sorry. And now the next thing is coffee break according to the program, and I believe we continue at 11.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations!
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never gonna get old, are we, Grandma?
I'm not.
People with passwords like password123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks,
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
what security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations!
Oh my God!
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never gonna get old, are we, Grandma?
I'm not.
People with passwords like password123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks,
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
what security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Just hello. Okay, we are live. So welcome to continuation after the coffee break. Our next talk is titled IPv6 Dual Stack in Kubernetes: Why, When, Where, and How. And I will introduce you, Rastislav Sabo. It's all yours.
Thank you. Thanks for introduction and thanks for organizing such a nice conference. Yeah, so this talk will be a bit about networking, a little bit deeper into networking, about IPv6 and dual stack in Kubernetes. But before going into that, let me introduce myself. My name is Rastislav Sabo. At the moment, I'm working as a software engineer at Isovalent, the company behind Cilium. It's quite new. I'm still a newbie there. But even before Isovalent, I had a privilege to work on many nice open source projects, such as Kubernetes platform, some other projects around Kubernetes, and in the past, some projects, open source projects around software-defined networking. I'm based in Banská Bystrica, Slovakia, and when I'm not working, I'm also a dad of 3-year-old boy, and I enjoy the time spent together with my family. And occasionally, I'm also an orienteering athlete or orienteering race organizer. So what's today's agenda? I would like to start with some introduction of IPv6 and why we need it. Then I would introduce dual stack networking. I'll show you how IPv6 and dual stack works in Kubernetes and how it can be enabled. And at the end of my presentation, I would go through some most common cloud platforms and talk about IPv6 and dual stack support across the cloud providers. And if we still have time, we can do some very short demo of dual stack with Cilium CNI. So before going to IPv6, let me start with IPv4. IPv4 is the core networking protocol of the internet still. It was standardized back in 1991, so like 40 years ago. And in basic words, it is used to transfer pieces of data that we call packets over the internet. And each packet contains sender and receiver address that we call IP address. And this IP address in IPv4 is a 32-bit integer value. And that's actually the problem of the IPv4 protocol. 2 to the power of 32 is only about 4 billion addresses, which is less than the current world population, which means that not everybody on this earth can have their own IPv4 address. And due to the lack of IPv4 addresses, they are almost unavailable in certain regions, like Asian and Pacific regions, and they are in general becoming very expensive resource. The workaround that we have applied to work around this IP address exhaustion issue is called network address translation, using which we can hide multiple hosts behind single IP address, but it brings some complexity and many limitations. So the next, or the real solution of the IP address, small IP address space problem is the IPv6 protocol, which is actually pretty old as well. It was drafted in December 1998. And the biggest benefit of it is that it provides a larger address space. So the IPv6 address is 128-bit integer value, which give us this amount of possible IP addresses, which is actually enough to address every single atom of the planet Earth. We use hexadecimal notation for IPv6 addresses, 8 groups of 16 bits each, separated by colons. You can see some examples there. Those two starting with 2001 are equivalent. And bed colon, cafe, 2 colons is also an IPv6 address. Thanks to this large address space, we do not need network address translation anymore, at least not because of lack of the addresses. One good benefit of IPv6 is that IPv4 can be transported or tunneled via IPv6 networks. And thanks to that, it was adapted quite early by telco and ISPs internally, especially in mobile networks, So many current internet users, even if they use IPv4, they don't even know that their packets actually traverse some part of their path via IPv6 network. What are some other benefits of IPv6 apart from the larger address space? First, it is more efficient routing, mainly because there is no need for network address translation, which itself requires a lot of processing. But also, there is, for example, no checksum calculation on each hop. IP fragmentation is not allowed by design. Another benefit is built-in security features, such as IPsec, which was natively incorporated during the design of IPv6. And the fact that each endpoint in the internet can have their own IPv6 address means that we have end-to-end transparency across whole network. So we can see at every single point of the network who is the originator and who is the destination of that packet. That is actually also an anti-security feature. Since we can have public IPs anywhere, it means that we may need more firewall rules. Apart from this, there are many other features like stateless address auto-configuration, which can replace DHCP, address mobility, so you can travel with your public IPv6 address across the globe. Extension headers, that's a mechanism that can be used to extend IPv6 to various different use cases. One of them, for example, being SRv6, and that's the one that I wanted to show you. It's quite complex stuff, but I just want to show you what's possible with IPv6, also with connection to Kubernetes. So segment routing for IPv6 is a network programming framework built on IPv6, which leverages source routing paradigm. Source routing means that whole path of the packet is encoded at the source of the segment routing domain. And what we call packet processing program is essentially a sequence of instructions that can be part of the IPv6 header or IPv6 extension header that we call segment routing header. And through that, we can do some clever things like traffic engineering. We can, for example, tell our packet to traverse some optimized low latency path through ISP network towards the other branch of your company. We can do VPNs, network service function chaining, etc. And everything natively via any IPv6 network. If you are interested more in segment routing, I would recommend KubeCon NA 2022 talk by Daniel Bernier from Bell Canada and my colleague Luis de los Santos from Isovalent. It's very interesting. But let me go back to IPv6 and IPv4. So as it turned out, we cannot just turn off IPv4 in our internet and start using IPv6 at a single point of time. So we need some meaningful transition strategy. And that transition strategy is dual stack. Dual stack actually means that dual stack enabled devices can support both protocols at the same time so that they can have both IPv4 and IPv6 addresses. They can use either IPv4 or IPv6 if supported by the remote end. And the decision is made based on which address family is returned from DNS lookup for a particular domain. But for that to work, we need support on multiple places. So if you look at, take a look at this picture, on the left side we have some home network with some network devices like mobile phone, laptops in our home, and on the right side we have some service provider. So first of all, if the right side is some Kubernetes cluster which is providing some service, that itself needs to have IPv6 or dual stack support. Then, of course, the ISP, the internet service provider that we use, needs to support both IPv4 and IPv6. And the CPE device, the device that the internet provider gave us to interconnect ISP network with the home network, needs to support it as well. And the home part of that configuration needs to be dual stack enabled as well. So all of this needs to work in order to have dual stack connectivity end-to-end. And why I'm talking about IPv6? The reason is that the IPv6 adoption is increasing. This graph shows the percentage of users that access Google services over IPv6 worldwide. And as you can see, we are approaching 40% of IPv6 adoption. So almost 40% of internet users already use IPv6 to connect to Google services. This picture shows how it looks like on individual countries basis. And if you want, you can make a quick guess in your head what country would be winning here. I'll give you 3 seconds, 1, 2, 3, and the winner is France. So in France, already over 70% of Google traffic or Google users traffic goes to Google via IPv6. And if you want to make another guess, I'll give you 3 more seconds and make your guess what would be the numbers for Czech Republic and Slovakia. 1, 2, 3. It's not that great. So in Czech Republic, it's about 24%, and in Slovakia, we are actually below 10%. So please, Slovak ISPs, if you hear me, please make something with that. Okay, what can we do to enable IPv6 in Kubernetes? IPv6 only Kubernetes clusters were possible since Kubernetes 1.9, so pretty early actually. But IPv6 only use case is pretty limited. I would say focus on specific use cases. Maybe if you want to run something like 5G core network on Kubernetes, then probably you would do it in IPv6 only Kubernetes cluster. But for general application use cases, you would probably want to serve both IPv6 and IPv4 clients. And that's exactly what dual-stack Kubernetes clusters allow us. Dual-stack Kubernetes is a feature which is generally available in Kubernetes since the version 1.23. And if dual-stack is enabled in your Kubernetes cluster, then every pod has an IP address from each address family, so both IPv4 and IPv6 address, which is actually the role of the CNI. And Kubernetes services can be declared either a single stack, which is default, or dual stack. You'll see in more detail in a second. In theory, each pod in your Kubernetes cluster can have a public IPv6 address, which also means that you may need more firewall rules in your cluster or in your setup. And unfortunately, in Kubernetes, we have not yet avoided network address translation, even if we use IPv6. The service load balancing is still based on network address translation at the moment. There is some work, or there's already some people thinking about how we could address that, but at the moment, each IPv6 or dual stack service would get assigned some virtual IPv6 address, which would be netted when the traffic goes to the backend pods. But as you may already know, in case that you are using Cilium CNI, a lot of network address translation can be avoided thanks to eBPF, which is actually the case for both IPv4 and IPv6. So you may take a look at that. Okay, now how you can enable dual stack in your Kubernetes cluster. This slide shows how you can do it the hard way. Of course, in case you are using some smart Kubernetes platform, which allows you to do it by a single click, that's possible for some platforms. But in general, your worker nodes need to have IPv4 and IPv6 addresses, both, for which you may need some support from your cloud provider. And then you need to enable it on 4 places in the control plane. So on kube API server, kube controller manager, kube proxy, and kubelet, you need to configure both IPv4 and IPv6 cluster IP ranges and pod IP ranges. And last but not least, you also need to configure your CNI to provide or work with both IPv4 and IPv6. In case of Cilium, you can do it quite easily in the Helm chart. You just set IPv6 enabled to true. IPv4 is enabled by default, so just by doing that, you can enable dual stack. Once dual stack is enabled in your cluster, if you describe your nodes, you would see that every single node in your cluster should have both IPv4 and IPv6 address. If you describe the pods, you would see on the first look that the pod looks like it would have only single IP address, but in fact, in the status of the pod, you would see both IPv4 and IPv6 address. And similarly for services, if you request a dual stack service, you would see that the service has both IPv4 and IPv6 address. Actually, since Kubernetes 1.21, each service spec has two new fields that you might have already seen. So there is spec IP family policy, through which you can define whether a service should be single stack or dual stack. Single stack is default, and in case of dual stack, you have two options: prefer dual stack or require dual stack. It works the same way, just require dual stack would give you an error in case that dual stack is not supported in the cluster. And another field is spec IP families, through which you can define which IP family you want to have for that service. So in case of single stack, you can define either IPv4 or IPv6. And in case of dual stack, you can actually define the order of IP families that you would like to use. It's not that important. The order is not that important, as at the end of the day, it still works the same way. But the order would give you a difference if you describe the service or get the service through the CLI. You'll see in a moment. So on the example on the right side, I have a service which is defined as prefer dual stack. So this one requests dual stack if it's available in the cluster, but would not fail if dual stack is not available in the cluster. And in the IP families, I specified the list IPv6 and IPv4, meaning that primarily the service would look like it has IPv6 service address, but it would also support IPv4. This is just an example. In case that you opt for not enabling dual stack in your cluster, you can still leave your cluster on single stack and use something like Cilium NAT46, NAT64 gateway for doing the translation for you for all the ingress or egress traffic. So this is a feature that is available in Cilium since release 1.13. You can take a look at the release notes if you are interested in more details. But essentially what it does, it allows you to have a single stack cluster and have a NAT gateway in front of it, which would allow you to also serve the traffic for the others family. Okay, and now I will talk about about the support of dual stack across some different cloud providers. I'll go through some major ones, then smaller ones, and some on-prem platforms. So in my humble opinion, AWS is leading here and provides best IPv6 dual stack support. In AWS, each VPC can get its own /56 public IPv6 subnet. You can bring your own IPv6 subnet if you want, and each VM can get any number of IPv6 addresses. Just if you are using AWS, you need to pay attention on which cloud controller manager you are using, because the AWS load balancer controller supports dual stack, but the standard AWS CCM does not. In case of Microsoft Azure, the dual stack or IPv6 support is a bit different, I would say, because the platform would give you only private IPv6 address range for addressing your nodes and networks. And you would need to request public IPv6 for VMs on per VM basis, and that VM would be that IP would be like virtual IP address that would be network address translated whenever the traffic is reaching your VM. And dual-stack load balancer services are not yet supported in Azure Cloud Control Manager. So in case of this platform, it's not yet there, but it's in progress, and I think it should be delivered in Kubernetes 1.28. In case of Google Cloud, there is pretty good dual-stack support for VPCs and for VMs, but dual-stack load balancer services are not yet supported. Smaller cloud providers, for example, Hetzner has very good IPv6 and dual-stack support, including load balancer services, so there everything works fine. In Equinix, pretty good IPv6 support, but not yet support for load balancer services. Similarly for DigitalOcean, pretty good IPv6 support on the node level, but not yet for load balancer services. And now private cloud and on-prem platforms. So for OpenStack, OpenStack in general has great IPv6 support in OpenStack itself, but there is the support in Kubernetes Cloud Controller Manager is limited. And even this limited support, actually, I contributed myself when I saw that it's pretty low-hanging fruit. The limitation is that your service can be either IPv4 or IPv6, not really dual-stack at the moment. In case of bare metal platforms or other on-premises platforms, of course, dual-stack and IPv6 needs to be supported in the underlying network. And for load balancer services, you can use, for example, MetalD, which supports dual-stack in both BGP or Layer 2 mode. Or you can use Cilium load balancer IP address management support. In this one, we are supporting dual-stack announcement via BGP. Okay, so to summarize this, I think IPv6 is a necessity due to IPv4 address exhaustion, but also brings many other features. The adoption is increasing, especially in some countries. Most of the internet traffic is already served via IPv6. Dual-stack can be used for smooth transition to IPv6, so we do not have to stop using IPv4 at a single moment, but we can do both for some period of time. In core Kubernetes, Kubernetes upstream, dual-stack is very well supported since Kubernetes 1.23. When it comes to cloud providers, at the node level, the IPv6 support is available at most cloud providers. But the support for external IPv6 load balancing is not that well at the moment. But on many platforms, it is already a work in progress and should be available soon. And while it is not available, you can still use node port to expose IPv6 services in the meantime, or dual-stack services in the meantime. Okay, that's for the theory, and now I would like to show you some very short demo. The demo that you can actually do yourself at any time. It is based on a kind cluster that is defined, as you can see on the left side of this slide. So it's a standard kind cluster where I set networking IP family dual. And I also disabled default CNI, as I'll be using Cilium in this cluster. And I also disabled kproxy in this cluster, as I'll be using kproxy replacement of Cilium. And on the right side, you can see how I installed Cilium into that cluster. That's pretty much standard thing, I would say. But what's marked with orange is IPv4 enabled equals true and IPv6 enabled equals true. That's how we enable dual stack on Cilium. Okay, now let me go to my console. So this is our cluster. As you can see, it is running Cilium. If you pay attention, you may see that kubeproxy is not running there, as I have disabled it. We are using kubeproxy replacement of Cilium. And in the default network namespace, I have two nginx pods, which look like they have only IPv4 address from this output. But if we describe the pods and explore the output a little bit in depth, we can see that each pod actually has two IP addresses, one IPv4 and one IPv6. Similarly, if I describe the nodes, or first I would get nodes. I have three nodes in my cluster. They look like they have only IPv4 internal IP, but if I describe them, you may see that the nodes actually have both IPv4 and IPv6 addresses. And if we explore the describe node output a little bit more, you would also see that we have two different pod siders allocated for each node. One is for IPv4 address family, and the other one is for IPv6 address family. So the pods on this node would be assigned this IPv4 addresses from this range and IPv6 addresses from this range. Okay, now I would run a new pod in my cluster, just running a shell in the pod. And if we take a look at the IP addresses or interfaces in this pod, you would see that on the ETH0 interface, we have one IPv4 address, and we do have one IPv6 address. This one is the, with the global scope, is the one that was allocated from the pod sider of the node. There is one more IPv6 address, which is a special IPv6 address that has just link local scope. Every IPv6 enabled device has this link local scoped IPv6 address, which is auto-allocated. And I don't know if I still can access, if I still can see the output of some pods. Okay, let me maybe go back. So let me describe some pod again. As you can see, this pod had two IP addresses, and we can try whether we can ping the pod through both IPv4 and IPv6. So I'll copy first the IPv6 address. I'll go into my temporary pod, and we can try curl into IPv4 address, and that is working. And we can also try curl to the IPv6 address of the pod. And that is working as well. But what's more interesting is the services. So if I describe the services in my cluster, I have already deployed them, and I deployed various different flavors of dual stack services. And as you can see on this output, some look like IPv4 and some of them look like IPv6. But I will describe them and I'll show exactly how it works. So I deployed one service which is dual stack with preference IPv4 first and IPv6 next. And you can see that it has two cluster IPs allocated. First is IPv4 and the second one is IPv6. I have kind of the same dual stack service, but with different order of address families. First is IPv6, and the second one is IPv4. Then I have a single stack service, which is IPv4 only, and has only IPv4 cluster IP. And then I have an IPv6 only service, which has IP families IPv6 only, and has IPv6 address family. Let's focus on one of them. Let's say this NGINX dual stack v4. So that's a dual stack service. I will go back into my pod. Hopefully it will work. Internet, maybe. But what I wanted to show is that if it worked, if I did NS lookup to that service name, you would see that I would get both IPv4 and IPv6 address in the replies. Actually, to my NS lookup request, the pod would send both A and 4A DNS request, and I would get response for both of them. So at this point, I can again use either one or the other. So I'll just try the IPv6 one. And, sorry. That works. And the last thing, I'll try IPv4 one, and that should also work. And that's it for the demo. If you want to play with dual stack, you can do it yourself. At Isoval and Com Labs, we have several handful labs that you can use to explore networking with Cilium yourself. This particular link would guide you to IPv6 networking and observability lab that you can run in your browser and play around with dual stack. Thank you.
Thank you very much. We have some questions, and we have still time to answer them. So first one, when do you expect that the majority of the internet will primarily use IPv6? And there's a second question in that question. Can there be another protocol in the meantime?
I don't think there will be another protocol other than IPv6. I think that one suits well for the needs that we have. As I already showed you, even complex stuff like segment routing is already possible with IPv6 because it is extendable. When do I expect? I really don't know. As you saw already, France is already primarily on IPv6. So it is really, the answer would be specific to individual countries.
And speaking of individual countries, what's the current situation with Slovak internet providers? Is there an IPv6 option?
Yeah, as I've shown on one of the pictures, so in Slovakia, about 10% of internet users are using IPv6 to connect to Google services. So some of them are already supporting it, but the majority not yet.
Perfect. And the last question, doesn't the additional processing power required for managing large number of firewall rules outweigh the saved processing power required for NAT?
Yeah, I think NAT has definitely more complex processing, or requires definitely more complex processing than access lists. Because NAT needs to store the state of each individual session, whereas for packet filtering, you pretty much just have a list of static rules. So,
thank you very much. That concludes our presentation. We will continue in 5 minutes, and we can thank the speaker with an applause.
Thank you.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations.
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Okay, it's 40, so we can continue. Our next presentation will be delivered by Martin Hauskrecht of Labyrinth Labs. And the title of the presentation is Unlocking the Power of Observability, Exploring the Benefits of Open Telemetry for Modern Cloud Applications. The presentation will be in Slovak, but you can ask questions in English. That's fine. Thank you.
Dobre, tak vítajte, ďakujem, že ste prišli. Volám sa Martin Hauskrecht, pracujem ako Head of Engineering vo firme Labyrinth Labs. A dnes by som vám chcel povedať trochu viac o koncepte, ktorý voláme Observability a konkrétne sa zamerať na jeden produkt alebo projekt, ktorý sa volá Open Telemetry. Na začiatku by som možno povedal niečo o nás ako o firme, čomu sa venujeme a potom by som prešiel k samotnej prezentácii. My ako Labyrinth Labs sa venujeme v podstate budovaniu a návrhu cloudových infraštruktúr pre našich klientov. Označujeme sa ako one-stop shop pre DevOps, Cloud a Kubernetes. Stavíme primárne infraštruktúry v public cloudoch postavené na Kubernetesoch alebo nejakých serverlessových technológiách. Aktuálne to robíme už 6 alebo možno už aj 7 rokov Je nás zatiaľ 20 a robíme to už aktuálne pre desiatky klientov a spravujeme teraz vlastne 100 a viac Kubernetes klastrov. Naša nejaká misia, ktorú sme si definovali, je transformovať firmy a biznisy na to, aby sa stali cloud natívnymi a niečo, čo my voláme future ready, alebo aby boli pripravené na budúcnosť. A to, čo vlastne robíme, je, že im pomáhame efektívne škalovať ich biznis tým, že pre nich stavíme stabilnú infraštruktúru, ktorá s nimi vie rásť a postupom času, ako oni rastú, tak sa vie prispôsobovať ich požiadavkám. No a teraz už k samotnej téme. Väčšina z vás podľa mňa už počula slovo observability, alebo aj vie asi, že čo to je, čomu sa to venuje. Ale na začiatok by som to chcel aspoň nejako trochu zadefinovať. Observability ako koncept vlastne rieši nejaký efektívny monitoring alebo sledovanie dynamických a distribuovaných systémov. Tie slova, že dynamické a distribuované sú v tomto kontexte dosť podstatné, dovysvetlíme, že prečo. To, čo to efektívne robí, je, že vlastne nám to umožňuje nájsť nejaký dôsledok a možno, že zistiť alebo namapovať k nemu nejakú príčinu, čo ho spôsobila. Môžeme si to možno predstaviť na nejakom jednoduchom príklade. Ten dôsledok môže byť niečo, že nám napríklad sa dvihnú latencie na nejakej aplikácii. A ten koncept observability alebo ten tooling okolo toho nám vlastne umožňuje toto zistiť. A potom zároveň ako keby sa dopátrať k príčine, čo to spôsobila. No a jednoducho povedané nám to dáva akoby nejakú visibilitu alebo nejakú viditeľnosť do celého toho systému, do celej architektúry a dávajú nám ako nejakým ľuďom, ktorí stavajú tú platformu alebo tým DevOpsakom, dáva to developerom, ktorí pre ňu vyvíjajú aplikácie a dáva to takisto aj napríklad rôznym analytikom, systémovým administrátorom a podobne. Observability je postavená alebo stojí na 3 pilieroch. Tie piliere sú metriky, logy a tracy, od nich ste už pravdepodobne počuli. A existuje množstvo toolov, ktoré vlastne sa dajú použiť na zber dát pre tieto piliere. Observability prináša aj nejaké výzvy so sebou, alebo respektíve adresuje nejaké výzvy. Jedna z nich je teda, že ako vlastne chceme sledovať komponenty nejakých dynamických a distribuovaných systémov. Toto je výzva hlavne preto, že keď tie systémy, a špeciálne keď sa bavíme o Kubernetoch alebo obdobných systémoch, ktoré sa vlastne škálujú hore-dole počas dňa, u nás je úplne bežné, že naše klastre sa, naškálujú na 4-násobok svojej veľkosti alebo naše serverlessové aplikácie na 10-násobku svojej bežnej prevádzkovej kapacity počas nejakých eventov. No a toto je pomerne ako keby výzva, že ako toto chcete sledovať, že ako vlastne budeme zisťovať to, že vznikajú nejaké nové pody, že zanikajú, že Kubernetes spawnuje nejaké nové nody. A ako ja tieto nody, pody, resursy objavím a začnem z nich zbierať dáta, ako ich budem ukladať, ako ich budem presúvať a tak ďalej. Takisto, čo to rieši, je to, ako sú jednotlivé služby, ktoré my prevádzkujeme na sebe závislé, alebo ako sa ovplyvňujú. Myslené to je tak, že pokiaľ my máme nejakú typickú už v dnešnej dobe asi microservisovú architektúru a ja ako user vykonám request voči nejakej našej aplikácii, tak v observability chcem riešiť aj to, že ako sa tieto služby, cez ktoré tento request preteká, ovplyvňujú alebo ako to ovplyvňujú nejaké ďalšie komponenty v tom našom prostredí. No a veľmi jednoducho povedané, akoby observability nám prináša to, že chceme vedieť, že čo sa deje, keď máme nejaký problém, keď robíme deployment, keď sa niečo v tom prostredí deje, chceme vedieť, ako sa správa, ako sa tie komponenty ovplyvňujú a chceme vedieť čo najviac informácií o nich. Okolo observability je extrémne veľa toolov, je to téma, ktorá je veľmi dominantná už niekoľko rokov a či už ako keby open sourceových toolov v tom CNCF stacku alebo manažovaných riešení, nejakých SaaSov, ktorých okolo toho vzniklo, je toho extrémne veľa. Určite poznáte Prometheus, to je asi najbežnejší tool, ktorý, keď riešite observability okolo Kubernetov, s ktorým sa stretnete, slúži to na zber metrík. Určite poznáte Elastic, ten sa typicky používal na zber logov, v dnešnej dobe už aj na metriky a tracy. Pravdepodobne ste počuli o Datadogu, čo je nejaká manažovaná služba, ktorá nám umožňuje zbierať všetky tieto dáta pre všetky 3 piliere. A StatsD a Splunku a Jaegery a CloudWatchy, čo je nejaká služba od AWS, zase, ktorá nám umožňuje zbierať metriky a logy. X-Ray, ktorá slúži na tracing, Zipkine, New Relicku, Lokim a tak ďalej. Hej, že tých toolov je extrémne veľa a mohol by som ich tu menovať ešte asi celý deň. No a To, čo majú ako keby, alebo respektíve to, čo tie túly riešia, tak každý rieši nejaký svoj špecifický problém. Každý môže byť v niečom lepší, každý môže byť možno, že špecializovaný na nejaký konkrétny use case a my si teraz môžeme vyberať z nich, že ktorý použijeme na ten náš. To, čo majú tie túly ale spoločné medzi sebou, je, že každý z nich musí riešiť tieto dva problémy. Ten prvý je, že keď chcem, aby som vôbec mal nejaké observability dáta alebo nejaké telemetry dáta, čiže aby som vytváral nejaké metriky, logy alebo tracy, tak musím svoje aplikácie na to nejako inštruovať. Musím mať nejakú inštrumentáciu na to, aby som vôbec takéto dáta produkoval. Tá inštrumentácia môže byť napríklad v podobe nejakej Prometheovej klientskej knižnice, ktorú ja si inkludnem do aplikácie a budem cez ňu vytvárať metriky, môže to byť nejaký logger, ktorý mám v aplikácii, môže to byť nejaký traceovacia knižnica alebo SDKčko. Ale to, čo vlastne všetky tie tooly majú spoločné, je to, že každý toto musí nejako riešiť, každý musí vyriešiť produkciu tých dát a každý to môže riešiť nejakým svojím spôsobom. Druhá vec, čo majú spoločné, je to, že každý musí riešiť aj presun tých dát, alebo že ako sa vlastne tie dáta budú enkodovať, ako sa budú presúvať, ako sa dostanú na nejaký ten backend. Každý z nich potom rieši aj to, že ako sa tie dáta budú ukladať, ako ich budeme queryovať a tak ďalej. Ale o týchto dvoch hlavných bodoch sa vlastne dneska chcem rozprávať. A chcel by som vám povedať, ako to rieši projekt, ktorý sa volá Open Telemetry, ktorý na to môže mať možno že trošku iný pohľad a snaží sa to robiť trochu agnosticky voči jednotlivým vendorom. Open Telemetry vlastne by sme mohli jednoduchosti charakterizovať ako nejaký set štandardizovaných vendor agnostických SDK-čiek API na toolov. To, čo nám to poskytuje, je vlastne nejaká vendor agnostická inštrumentačná knižnica, respektíve niekoľko knižníc, každý jazyk má svoju. No a takisto nám to dáva nejaký vendor neutrálny kolektor. Okrem toho Open Telemetry takisto prišlo s nejakým svojím protokolom, ktorý sa volá OTLP, alebo Open Telemetry protokol. No a tento vlastne opisuje to, ako my vieme jednotlivé tie telemetry dáta enkodovať a transportovať alebo presúvať. Aktuálne Open Telemetry CNCF Incubating Projectom vzniklo v roku 2019 v máji a vzniklo takým spôsobom, že sa vlastne spojili dva projekty, ktoré sa volali Open Census a Open Tracing. No a Open Telemetry sa vlastne snažilo riešiť ten problém, že každý ten vendor, ktorý nám umožňoval zbierať nejaké telemetry dáta alebo konkrétne tracy v tomto prípade, to robil nejakým spôsobom. A Open Telemetry do tohto prinieslo nejaký štandard alebo nejaký spôsob, ako to robiť vlastne agnosticky voči tým vendorom a možno, že získať takto trošku viac benefitov, o ktorých môžeme hovoriť aj ďalej. To, čo Open Telemetry nie je, a to by som chcel zdôrazniť, lebo to je častý omyl, ktorý ľudia robia, je, že Open Telemetry nie je observability backend. Open Telemetry nie je to, čo je Prometheus, nie je to, čo je Loki, alebo nie je nič obdobné. Nerieši to, ako sa dáta ukladajú, nerieši to, ako tie dáta môžeme queryovať, nerieši nič z tohto. To, čo Open Telemetry rieši, alebo na čo sa zameriava, je vlastne vytváranie tých jednotlivých signálov, alebo tých logov, metrik a traceov a ich prenos. To sú tie dve oblasti, vlastne, ktoré nám Open Telemetry vie nejakým spôsobom pokryť. Nejaké hlavné benefity, prečo vlastne by som chcel používať Open Telemetry namiesto tých jednotlivých inštrumentácií od vendorov, jednotlivých observability, je to, že nám to poskytuje vlastne jednotné API, jednotné SDK pre každý jazyk a prináša nám to vlastne vendor neutralitu. No a pod vendor neutralitou myslím to, že pokiaľ ja môžem používať Open Telemetry ako nejakú jednotnú inštrumentačnú vrstvu, tak mi to umožňuje vlastne za prvé ako keby začať vyvíjať tú aplikáciu a začať produkovať tie telemetry dáta bez toho, aby som vedel, že aký observability backend v konečnom dôsledku chcem použiť. Umožňuje mi to robiť to, že tých backendov môžem používať kľudne aj viac, respektíve to, že ich môžem v priebehu času nejako meniť podľa toho, ako sa mi to bude hodiť. Je to výhoda pre tých developerov, keďže nemusia v zásade vedieť, že čo na tom konci bude. A je to výhoda aj pre nás, pre ľudí, ktorí vlastne stavajú tie observability stacky alebo stavajú tie platformy, kedy pokiaľ by sme došli do stavu, kedy každá aplikácia bude inštrumentovaná cez Open Telemetry, tak si môžeme vyberať tie backendy podľa toho, aký je najvhodnejší use case. a nemusíme zasahovať priamo do aplikácie. Nemusíme tú aplikáciu meniť, nemusíme akoby dodatočne generovať robotu pre tých vývojárov, aby vlastne robili v tej aplikácii zmeny a došli sme za nimi, že chceme, aby ste použili Prometheus miesto Datadogu, tak aby si tam inkludovali nejakú Prometheovú knižnicu alebo sme spawnovali nejaký nový exporter. No a prvá vec, o ktorej by som sa chcel pri OpenTelemetry baviť, je tá inštrumentácia. Pod inštrumentáciou si môžeme predstaviť to, že ako vlastne my tej aplikácii povieme, že chceme, aby generovala tie telemetry dáta, čiže chceme, aby generovala nejaké tracy, chceme, aby generovala nejaké metriky a chceme, aby generovala nejaké logy. Môžete si to typicky predstaviť presne ako nejakú Prometheovú klientskú libku alebo ja neviem, nejaký logger a podobne. Toto je to, čo OpenTelemetry rieši a prináša teda nejaké SDKčka, ktoré si môžeme my inkludnúť alebo nejaké API, ktoré môžeme používať. No a sú dva také typy tej inštrumentácie, ktoré vlastne my v rámci OpenTelemetry môžeme používať. Jedna z nich je manuálna, a to je asi tá najbežnejšia. Manuálna inštrumentácia vlastne znamená, že si do svojho kódu musíte pridať kus observability kódu alebo priamo inkludnúť to SDKčko a musíte tam vlastne vyslovene vyprodukovať tie metriky, produkovať tie logy, produkovať tie tracy. Toto je taký veľmi, veľmi jednoduchý príklad, je to nejaká Go aplikácia, kde naľavo vlastne vidíte to, že ja tam inkludujem, respektíve toto je vybrané z OpenTelemetry dokumentácie, takže kľudne si to pozriete potom detailnejšie, kde naľavo sú inkludované teda nejaké package, ktoré mi umožňujú používať vôbec to SDKčko, používať ten tracing, ktorý tuto chcem ukázať. No a napravo mám definovaný nejaký handler, kde vlastne inicializujem nejaký tracer a pod ním teda by som mohol pridať nejakú svoju business logiku, ale týmto spôsobom ja vlastne priamo v mojej aplikácii začínam produkovať nejaké telemetry dáta, priamo zásahom do nej. Toto je akoby asi taký najbežnejší spôsob, špeciálne keď sa bavíme o nejakých logoch a metrikách. No a môže to byť pomerne pracné, že viete si asi predstaviť, že keď toto chcem riešiť nejako komplexne, tak môže to generovať celkom slušný overhead na strane tej aplikácie a hlavne to vyžaduje do nej nejaký zásah. To znamená, že pokiaľ mám aplikáciu, ktorá vôbec neriešila napríklad tracing doteraz, tak robiť manuálnu inštrumentáciu znamená, že ja musím do nej spraviť nejaký zásah a musím ju upraviť tak, aby to vedela robiť. Druhý spôsob, ten zaujímavejší v tomto prípade, je vlastne automatická inštrumentácia, ktorú nám OpenTelemetry poskytuje. No a tento koncept automatickej inštrumentácie vlastne hovorí o tom, že môžem inštruovať tú aplikáciu, aby produkovala nejaké telemetry dáta, v tomto prípade sa budeme hovoriť o traceoch, bez nejakého zásahu do nej, bez nejakého priameho zásahu. To, ako sa to robí, je dosť závislé od konkrétnej implementácie alebo konkrétneho jazyka, keďže tu dosť závisí aj napríklad keďže toto dosť závisí aj napríklad od toho, že či je jazyk kompilovaný, či je interpretovaný, v každom prípade to môže byť trošku iné. Tento princíp sa rieši buď nejakou manipuláciou kódu alebo takým mechanizmom, ktorý máme monkey patching, alebo sa tu môžu využívať také technológie ako eBPF, o čom tu už asi jedna prednáška dneska bola. No a závisí to teda od konkrétneho použitia, že keď sa budeme baviť o nejakom JavaScripte, tak môžeme asi využiť mechanizmus nejakého monkey patchingu, keď sa budeme baviť o kompilovanom jazyku, ako je Go, tak pravdepodobne budeme musieť použiť práve eBPF alebo niečo obdobné. OpenTelemetry takisto poskytuje Kubernetes operátora, ktorý toto do nejakej miery rieši. Ten Kubernetes operátor, okrem toho, že teda plní ešte nejaké iné funkcie, ale to, čo nám umožňuje, je vlastne pomocou nejakých custom resourceov definovať vlastne túto autoinštrumentáciu a robiť tam akoby nejaký automatický injection do mojich podov a akoby začať produkovať tie tracy a vykonávať tam tú autoinštrumentáciu. To je jeden spôsob, ako sa to dá riešiť. Iný spôsob, ktorý tu mám zase vytiahnutý z OpenTelemetry dokumentácie, je, toto je konkrétne teda nejaký príklad pre TypeScript, je, že si vedľa svojej aplikácie ja definujem teda nejaký kus kódu, kde mám inicializovaný práve tú autoinštrumentáciu alebo to SDKčko. A toto nie je ako keby súčasť tej mojej aplikácie. Toto je nejaká separátna standalone vec, ktorú ja následne pri štarte svojej aplikácie cez nejaký require flag tu viem zabezpečiť, aby sa to naštartovalo najprv a následne sa spúšťala samotná moja aplikácia. To, čo mi to vlastne umožňuje robiť, je to, že začínam tuto produkovať tie tracy bez toho, aby som robil nejakú priamu aplikačnú zmenu. Tú automovú inštrumentáciu si veľmi v jednoduchosti môžete predstaviť tak, že pokiaľ, ja neviem, v nejakom svojom TypeScriptovom backende používam knižnicu, ktorá chodí do Postgresu a vykonáva tam nejaké queryny, tak pomocou tohto monkey patchingu a automatickej inštrumentácie ja viem priamo v runtime tej aplikácie akoby obohatiť, poviem slovo, že obohatiť, pri vykonávaní tej metódy to, že vlastne začínam tam produkovať nejaké telemetry dáta, začínam tam produkovať nejaké tracy. No a to mi môže napríklad umožniť to, že pri vykonávaní nejakej queryny do databázy začnem sledovať to, že koľko tá queryna trvala. Alebo že ja neviem, do akých stĺpcov šahala, alebo podobné dáta. Môžem to robiť takisto pri vykonávaní nejakých post requestov alebo podobne, nejaké externé APIny. Môžem to používať pri DNS resolvingu a trilión ďalších veciach, ktoré tie SDKčka podporujú nejako out of the box. Je to dosť závislé od konkrétneho jazyka a konkrétnej implementácie. V tej dokumentácii OpenTelemetry máte príklady vlastne pre každý jazyk, ktorý je podporovaný, čiže kľudne si to pozrite viac, ako vás to zaujíma. No a to bol ten prvý problém, že ako vôbec nainštruovať tú aplikáciu na to, aby tie telemetry dáta produkovala. No a druhý problém, ktorý tu riešime, je, ako vlastne tie dáta zbierať a ako ich možno presúvať. Jeden taký akoby najjednoduchší spôsob, ako to robiť, je, že ja viem vlastne tie telemetry dáta posielať priamo z aplikácie na nejaký backend. Čiže viem priamo posielať tracy zo svojej aplikácie na, neviem, Grafana Tempo, alebo na Jaeger, alebo na X-Ray, alebo niečo obdobné. Je to ten najjednoduchší spôsob v zmysle, že nepotrebujem žiadne ďalšie komponenty a viem proste cez nejaký environment premene alebo nejaký obdobný spôsob definovať nejaký endpoint pre svoju aplikáciu. A to je OpenTelemetry SDKčko začne posielať tie tracy alebo tie telemetry dáta na nejaký backend. Ten spôsob je najjednoduchší, ale asi aj v konečnom dôsledku môže byť najproblematickejší. A to v tom, že vlastne ja celý ten heavy lifting nechávam na tú svoju aplikáciu. To znamená, že pokiaľ napríklad budem mať nejaký problém s tým svojím backendom, tak už tá aplikácia by mala vedieť handlovať nejaký retry mechanizmus alebo nejaký spôsob bufferingu alebo nejaký spôsob batchovania a tak ďalej. Takisto vytváram tam možno, že nejaký dodatočný overhead v tej aplikácii, ktorý ju môže akoby dodatočne zaťažiť. OpenTelemetry prichádza aj s vendor agnostickým kolektorom, ktorý toto šťastie vie adresovať. No a tento kolektor akoby slúži na to, aby sme my vedeli príjmať, procesovať a ďalej exportovať tieto telemetry dáta. Ten kolektor má zmysel používať v niektorých prípadoch. Jeden z nich môže byť, že pokiaľ ja chcem posielať tie moje telemetry dáta na viacero backendov, ak mám na to nejaký use case, že chcem používať viacero služieb, viacero observability backendov, tak priamo cez ten kolektor viem toto pomerne efektívne spraviť bez toho, aby aplikácia vlastne musela o tých backendov vedieť. Takisto je vhodné to používať, pokiaľ chcem ja tie svoje metriky alebo nejako napríklad transformovať, robiť tam nejaký relabeling a podobne. Alebo chcem, ja neviem, zmeniť názvy spanov v tých traceoch predtým, ako sa dostanú na ten samotný backend. Celkom dobrý prípad môže byť, alebo celkom dobré použitie môže byť aj to, pokiaľ chcem ja tie svoje telemetry dáta nejako enrichnúť, chcem tam pridať nejaké metadáta. No a konkrétne v prípade Kubernetesu to môže byť napríklad to, že chcem vedieť, z akého podu mi tie telemetry dáta prichádzajú, alebo na akom node ten pod bežal, alebo nejaké dáta, ktoré vlastne tá aplikácia nevyhnutne samotná mať nemusí, ale ja by som ich chcel v tých telemetry dátach mať. Tak toto práve môže robiť ten kolektor, ktorý v tom klastri beží a má už ako keby kontext aj takýchto vecí. No a v neposlednom rade teda to viem využiť na offloadnutie tej práce posielania vlastne tých dát na ten backend. Čiže ten kolektor mi poskytuje zároveň nejaký mechanizmus bufferingu, nejaký retry mechanizmus, nejaký mechanizmus batchovania a tak ďalej. Čiže dá sa to akoby celkom efektívnym spôsobom offloadnúť táto práca z tej aplikácie na ten samotný kolektor. V praxi to môže vyzerať asi nejako takto. Ten kolektor my typicky deployujeme normálne do Kubernetes klastra. Môžete si to predstaviť, ak ste niekedy používali, ja neviem, Datadog, tak tiež ste mali asi nejakého agenta v klastri, alebo Grafana Cloud, alebo niečo obdobné, možno, že aj niečo ako FluentD, alebo podobné by sa k tomu dalo prirovnať. Je to niečo, čo vlastne beží v tom klastri a ja inštruujem svoje aplikácie, ktoré môžu byť teda inštruované buď autoinštrumentáciou, alebo to manuálnou na to, aby vlastne posielali tie telemetry dáta na tento kolektor. Takisto viem inštruovať nejaké externé servisy, neviem, niečo z AWS napríklad, alebo nejaké ďalšie servisy na to, aby tieto dáta na ten kolektor poslali. Ten kolektor ich vie nejako procesovať, ak mám o to záujem, vie ich nejako enrichnúť. No a následne ich vie poslať na nejaký ten backend, ktorý je podporovaný, čiže do nejakej time series databázy, do nejakej traceovacej databázy a tak ďalej. Toto je jeden z takých akože najbežnejších asi modelov deploymentu toho kolektora. Myslím, že ten kolektor môže byť deployovaný aj cez OpenTelemetry operátor, nie som si istý, ale predpokladám, že áno. No a tá najbežnejšia forma sa volá vlastne agent, kedy ten kolektor mi beží v klastri ako nejaký agent, a ako som povedal, teda tie aplikácie posielajú cez OTLP protokol, telemetry dáta na ten kolektor, on ich príjme, sprocesuje, exportne, pošle ich na nejaký backend, pošle ich, ja neviem, keď sa budeme baviť zase o tom tracingu, tak pošle ich na Grafana Tempo napríklad. Druhý spôsob je, voláme gateway. No a ten gateway je trošku komplikovanejšia architektúra v tom, že ja viem napríklad aj tie kolektory reťaziť za sebou. Môže to byť vhodné v prípade, ak máme možno, že nejaký šerovaný observability stack, kedy zbierame dáta z viacerých klastrov na nejaké jedno miesto. No a ten kolektor mi umožňuje vlastne robiť aj to napríklad, že akoby budem ich mať vrstvených alebo reťazených za sebou. Čiže pošlom svoje telemetry dáta na jeden kolektor, ten s nimi niečo spraví, možno tam niečo doplní a mám niekoľko takýchto kolektorov ešte vedľa toho, ktoré môžu robiť nejakú inú funkciu. No a v konečnom dôsledku to môže skončiť na nejakom spoločnom kolektore, ktorý tam doplní nejaké dodatočné metadáta a pošle to už na ten backend. No a na záver by som akoby sa chcel povedať o nejakom praktickom využití v dnešnom svete, že nakoľko vlastne toto je prakticky využité aktuálne. OpenTelemetry začalo s tracingom a to je akoby najstabilnejšia aktuálne časť toho OpenTelemetry. Stabilný je protokol, SDK je API. No a pravdepodobne dneska, keď používate alebo generujete nejaké tracy, posielate ich nejaký backend, tak je dosť možné, že už využívate OpenTelemetry, že už podporujú to vendory ako Datadog, AWS, Grafana Tempo a tak ďalej. Ich strašne veľa, ten zoznam je dokumentácie OpenTelemetry, keď chcete. Ale je to pomerne adaptovaný štandard, čo sa týka tracingu aktuálne. Čiže ak budete riešiť niekedy tracing, pravdepodobne to budete robiť cez OpenTelemetry. Čo sa týka metrík, tam je to už trošku zložitejšie, kedy vlastne protokol je nejako zadefinovaný, už máme aj nejaké stabilné API, stav tých SDKček je taký, že niektoré sú, niektoré nie sú. No a v reálnom svete sa myslím si, že toto ešte moc nepoužíva, že generovať metriky cez OpenTelemetry som ja teda ešte moc nevidel. A stále ako keby vo väčšine prípadov sa používa čisto Prometheus alebo nejaké obdobné riešenie. Ale smerujeme vlastne k tomu, aby sme aj metriky generovali cez OpenTelemetry a možno, že používali to rovnakým spôsobom, ako používame tracing v tomto prípade. No a čo sa týka logingu, tak to je najväčšia bieda aktuálne. Tam je to všetko v takom experimentálnom stave a zatiaľ s tým asi veľa nenavýmyšľate. Ale verím tomu, že raz sa tam dostaneme a budeme mať teda ten ideálny svet, kedy budeme používať jednu inštrumentáciu na produkciu všetkých týchto telemetry dát a nebudeme musieť potom presviečať ľudí, aby prešli na to alebo to, lebo je to lepšie. No a OpenTelemetry je akoby dosť podporovaná už aj v nejakom CNCF toolingu. Ten zoznam zase je v dokumentácii, ale neviem, Tracy v OpenTelemetry generuje Nginx ingress napríklad už. Priamo Kubernetes to do nejakej miery podporuje, BuildX, Docker to nejako podporuje a tak ďalej. Že je to už pomerne taký adaptovaný štandard a budete sa s tým stretovať asi pomerne často. Dobre, za mňa je to všetko. Ak vás to zaujíma, kľudne sa pýtajte, kľudne mi napíšte, rád sa o tom porozprávam, aj tuto ešte tú chvíľku budem, takže príjmam otázky.
Thank you very much for the presentation. We have some questions. The first one is, which visualization service has worked for you to visualize open telemetry data? Have you tried displaying trace logs and metrics in one place?
Okay, I'll answer in English. We usually use Grafana as the visualization layer. That's the one tool that we have the most success with. With traces, we usually use Grafana Tempo, which is a good fit for this. And we also try to, well, we're definitely visualizing the data in one place. So we have like logs, metrics, and traces in Grafana. You can combine logs and metrics in dashboards. And for traces, you can use the Explore tab that is there. But we also try to correlate the data between each other. So Prometheus has this concept called exemplars, and with logs you can pretty easily correlate them by including some trace IDs, and then you can just click around and switch between logs and traces.
Thank you. The next question is OpenTelemetry currently ready for production?
For tracing, yes, definitely. For the rest of the stuff, probably not.
Thank you. That concludes our presentation. And the next on the agenda is lunch. So enjoy your lunch. Thank you for your attention and see you in the afternoon.
As a modern IT leader, your team's role has expanded beyond supporting business operations and enabling incremental change. Today, the organization relies on you and your team to leverage technology investments to drive innovation. But resources are always limited. And there's another challenge that's making it difficult to meet those expectations: architectural complexity. At F5, we believe that rethinking your IT architecture can help you ensure that your people and systems can deliver maximum value today and enable the innovation the business needs for the future. To move toward a more secure, more agile, and more adaptable system that's easier to manage across clouds, we recommend provisioning services in 4 primary tiers: global, site, application, and management and operations. Start by deciding which services and controls you need at each tier. At the global tier, you can deploy general policies and standardized infrastructure requirements that will be applied universally across all sites and all applications. At the site level, you can specify policies that deviate from your global policy. These site-wide policies should only contain exceptions that apply at the given locale. At the application level, you can define application-specific policies. This layer can ignore site and global level policies and only focus on ones that are unique to a specific application. Finally, at the independent management and operations tier, in general, you can manage the code, configuration, infrastructure and policy rules, and analytics, keeping those requirements global, yet safely isolated from the 3 production tiers. With the right tooling, automation, and processes in place, you can boost operational performance and benefit from positive feedback loops with machine learning systems. Although these are conceptual tiers, they're a great way to simplify operations, consolidate services, and unify your application security and delivery policies. By rethinking your IT architecture, you can enable your developers to have a simple, secure path to speedier deployments, your security and network teams to control and update security and network policies without slowing down production, and your system to be more flexible and resilient in the face of constant change. Learn more and start today at f5.com/adaptiveapps.
Meet Anna and John. They are database admins working on different teams. Anna's team is using an open source database system. Although databases are free to use by developers, hiring for skill sets and maintaining versions are overwhelming tasks. John's team is using the public cloud. However, they get locked to the system into one deployment model. The services are expensive, and they also face hiring challenges. There's another gold standard option for Anna and John's teams. Portworx Data Services. Portworx Data Services is the one platform to deploy, operate, and secure any database with a few clicks via a single pane of glass. With Portworx, developers can push apps and features in production 2 times faster. Database admins can be 3 times more productive. Database teams can save up to 75% cost of underlying cloud storage. Developers can build fault-tolerant, highly secure, and reliable apps and data. Database admins can deploy and run any database on Kubernetes. Portworx turns your database admins into superheroes.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations.
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As a modern IT leader, your team's role has expanded beyond supporting business operations and enabling incremental change. Today, the organization relies on you and your team to leverage technology investments to drive innovation. But resources are always limited. And there's another challenge that's making it difficult to meet those expectations: architectural complexity. At F5, we believe that rethinking your IT architecture can help you ensure that your people and systems can deliver maximum value today and enable the innovation the business needs for the future. To move toward a more secure, more agile, and more adaptable system that's easier to manage across clouds, we recommend provisioning services in 4 primary tiers: global, site, application, and management and operations. Start by deciding which services and controls you need at each tier. At the global tier, you can deploy general policies and standardized infrastructure requirements that will be applied universally across all sites and all applications. At the site level, you can specify policies that deviate from your global policy. These site-wide policies should only contain exceptions that apply at the given locale. At the application level, you can define application-specific policies. This layer can ignore site and global level policies and only focus on ones that are unique to a specific application. Finally, at the independent management and operations tier, in general, you can manage the code, configuration, infrastructure and policy rules, and analytics, keeping those requirements global, yet safely isolated from the 3 production tiers. With the right tooling, automation, and processes in place, you can boost operational performance and benefit from positive feedback loops with machine learning systems. Although these are conceptual tiers, they're a great way to simplify operations, consolidate services, and unify your application security and delivery policies. By rethinking your IT architecture, you can enable your developers to have a simple, secure path to speedier deployments, your security and network teams to control and update security and network policies without slowing down production, and your system to be more flexible and resilient in the face of constant change. Learn more and start today at f5.com/adaptiveapps.
Anna and John. They are database admins working on different teams. Anna's team is using an open source database system. Although databases are free to use by developers, hiring for skill sets and maintaining versions are overwhelming tasks. John's team is using the public cloud. However, they get locked to the system into one deployment model. The services are expensive, and they also face hiring challenges. There's another gold standard option for Anna and John's teams. Portworx Data Services. Portworx Data Services is the one platform to deploy, operate, and secure any database with a few clicks via a single pane of glass. With Portworx, developers can push apps and features in production 2 times faster. Database admins can be 3 times more productive. Database teams can save up to 75% cost of underlying cloud storage. Developers can build fault-tolerant, highly secure, and reliable apps and data. Database admins can deploy and run any database on Kubernetes. Portworx turns your database admins into superheroes.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations! Oh my God, I got each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As a modern IT leader, your team's role has expanded beyond supporting business operations and enabling incremental change. Today, the organization relies on you and your team to leverage technology investments to drive innovation. But resources are always limited. And there's another challenge that's making it difficult to meet those expectations: architectural complexity. At F5, we believe that rethinking your IT architecture can help you ensure that your people and systems can deliver maximum value today and enable the innovation the business needs for the future. To move toward a more secure, more agile, and more adaptable system that's easier to manage across clouds, we recommend provisioning services in 4 primary tiers: global, site, application, and management and operations. Start by deciding which services and controls you need at each tier. At the global tier, you can deploy general policies and standardized infrastructure requirements that will be applied universally across all sites and all applications. At the site level, you can specify policies that deviate from your global policy. These site-wide policies should only contain exceptions that apply at the given locale. At the application level, you can define application-specific policies. This layer can ignore site and global level policies and only focus on ones that are unique to a specific application. Finally, at the independent management and operations tier, in general, you can manage the code, configuration, infrastructure and policy rules, and analytics, keeping those requirements global, yet safely isolated from the 3 production tiers. With the right tooling, automation, and processes in place, you can boost operational performance and benefit from positive feedback loops with machine learning systems. Although these are conceptual tiers, they're a great way to simplify operations, consolidate services, and unify your application security and delivery policies. By rethinking your IT architecture, you can enable your developers to have a simple, secure path to speedier deployments, your security and network teams to control and update security and network policies without slowing down production, and your system to be more flexible and resilient in the face of constant change. Learn more and start today at f5.com/adaptiveapps.
Anna and John. They are database admins working on different teams. Anna's team is using an open source database system. Although databases are free to use by developers, hiring for skill sets and maintaining versions are overwhelming tasks. John's team is using the public cloud. However, they get locked to the system into one deployment model. The services are expensive, and they also face hiring challenges. There's another gold standard option for Anna and John's teams. Portworx Data Services. Portworx Data Services is the one platform to deploy, operate, and secure any database with a few clicks via a single pane of glass. With Portworx, developers can push apps and features in production 2 times faster. Database admins can be 3 times more productive. Database teams can save up to 75% cost of underlying cloud storage. Developers can build fault-tolerant, highly secure, and reliable apps and data. Database admins can deploy and run any database on Kubernetes. Portworx turns your database admins into superheroes.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations. Oh my God, I got each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As a modern IT leader, your team's role has expanded beyond supporting business operations and enabling incremental change. Today, the organization relies on you and your team to leverage technology investments to drive innovation. But resources are always limited. And there's another challenge that's making it difficult to meet those expectations: architectural complexity. At F5, we believe that rethinking your IT architecture can help you ensure that your people and systems can deliver maximum value today and enable the innovation the business needs for the future. To move toward a more secure, more agile, and more adaptable system that's easier to manage across clouds, we recommend provisioning services in 4 primary tiers: global, site, application, and management and operations. Start by deciding which services and controls you need at each tier. At the global tier, you can deploy general policies and standardized infrastructure requirements that will be applied universally across all sites and all applications. At the site level, you can specify policies that deviate from your global policy. These site-wide policies should only contain exceptions that apply at the given locale. At the application level, you can define application-specific policies. This layer can ignore site and global level policies and only focus on ones that are unique to a specific application. Finally, at the independent management and operations tier, in general, you can manage the code, configuration, infrastructure and policy rules, and analytics, keeping those requirements global, yet safely isolated from the 3 production tiers. With the right tooling, automation, and processes in place, you can boost operational performance and benefit from positive feedback loops with machine learning systems. Although these are conceptual tiers, they're a great way to simplify operations, consolidate services, and unify your application security and delivery policies. By rethinking your IT architecture, you can enable your developers to have a simple, secure path to speedier deployments, your security and network teams to control and update security and network policies without slowing down production, and your system to be more flexible and resilient in the face of constant change. Learn more and start today at f5.com/adaptiveapps.
Meet Anna and John. They are database admins working on different teams. Anna's team is using an open source database system. Although databases are free to use by developers, hiring for skill sets and maintaining versions are overwhelming tasks. John's team is using the public cloud. However, they get locked to the system into one deployment model. The services are expensive, and they also face hiring challenges. There's another gold standard option for Anna and John's teams. Portworx Data Services. Portworx Data Services is the one platform to deploy, operate, and secure any database with a few clicks via a single pane of glass. With Portworx, developers can push apps and features in production 2 times faster. Database admins can be 3 times more productive. Database teams can save up to 75% cost of underlying cloud storage. Developers can build fault-tolerant, highly secure, and reliable apps and data. Database admins can deploy and run any database on Kubernetes. Portworx turns your database admins into superheroes.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations! Oh my God, I got each other.
For our neighbors.
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
Titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As a modern IT leader, your team's role has expanded beyond supporting business operations and enabling incremental change. Today, the organization relies on you and your team to leverage technology investments to drive innovation. But resources are always limited. And there's another challenge that's making it difficult to meet those expectations: architectural complexity. At F5, we believe that rethinking your IT architecture can help you ensure that your people and systems can deliver maximum value today and enable the innovation the business needs for the future. To move toward a more secure, more agile, and more adaptable system that's easier to manage across clouds, we recommend provisioning services in 4 primary tiers: global, site, application, and management and operations. Start by deciding which services and controls you need at each tier. At the global tier, you can deploy general policies and standardized infrastructure requirements that will be applied universally across all sites and all applications. At the site level, you can specify policies that deviate from your global policy. These site-wide policies should only contain exceptions that apply at the given locale. At the application level, you can define application-specific policies. This layer can ignore site and global level policies and only focus on ones that are unique to a specific application. Finally, at the independent management and operations tier, in general, you can manage the code, configuration, infrastructure and policy rules, and analytics, keeping those requirements global, yet safely isolated from the 3 production tiers. With the right tooling, automation, and processes in place, you can boost operational performance and benefit from positive feedback loops with machine learning systems. Although these are conceptual tiers, they're a great way to simplify operations, consolidate services, and unify your application security and delivery policies. By rethinking your IT architecture, you can enable your developers to have a simple, secure path to speedier deployments, your security and network teams to control and update security and network policies without slowing down production, and your system to be more flexible and resilient in the face of constant change. Learn more and start today at f5.com/adaptiveapps.
Meet Anna and John. They are database admins working on different teams. Anna's team is using an open source database system. Although databases are free to use by developers, hiring for skill sets and maintaining versions are overwhelming tasks. John's team is using the public cloud. However, they get locked to the system into one deployment model. The services are expensive, and they also face hiring challenges. There's another gold standard option for Anna and John's teams. Portworx Data Services. Portworx Data Services is the one platform to deploy, operate, and secure any database with a few clicks via a single pane of glass. With Portworx, developers can push apps and features in production 2 times faster. Database admins can be 3 times more productive. Database teams can save up to 75% cost of underlying cloud storage. Developers can build fault-tolerant, highly secure, and reliable apps and data. Database admins can deploy and run any database on Kubernetes. Portworx turns your database admins into superheroes.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker.
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations! Oh my God! I got each other.
For our neighbors.
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
Titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
Okay, I think we can slowly start. Good afternoon, everyone. Welcome to our panel discussion about observability. I think you noticed that the observability is nowadays a big topic also within this conference. So many talks on it, and I'm really like that I can be here today with all the experts who had also talks or help us with the organization, be part of this this panel. And before we start, we would like to ask you a few questions, maybe. So, how many of you are here developers? Just raise your hand. Okay, so most of the people. Do we have any SRE? Okay, so 4 maybe. And how many of you are very new to the observability topic? Okay, perfect. And do we have many people who are working on daily basis on observability? Okay. Thank you. So I guess we have a nice crowd here. And before we start, please don't be shy to ask questions. We have a Slido, so I will try to check it, but put questions there, and we will get back to them at the end of the panel. And you can also ask questions if you want to speak up, okay? Now I would like to give a word to our speakers and introduce themselves a bit and tell us why they are part of this panel. So maybe, Miro, we can start with you.
Okay. I'm Miro Adami. I work for a company Pivot3, which you probably never heard about. It's a Canadian company. I work for the Spanish office for the European office, which is in Spain, of the company. We do many things, and I particularly work in the infrastructure and cloud department. I'm some sort of like DevOps/SRE role. You can find us on the web at pivot3.com, and there are people that explain much better than I would what we do. The reason why I'm on this panel, because my good friend asked me to, and he believes that I have something relevant to say, which is something that I'm not 100% convinced of, but well, I'm here.
Hi, I'm Zdeněk Vania. I'm working for Prussia Research as a cloud and DevOps team lead. And in my free time, I'm organizing the community in the Prague. I'm in the Cloud Native Prague meetups and also this event. So maybe it's the reason why I'm here. Because one of my responsibilities is also the observability stack. So that's it.
Hi, everyone. I'm Gautam. I work at Grafana Labs, but I started off as a Prometheus maintainer like 6 years ago, worked on the storage engine and on the general Prometheus maintenance for a while, and then on Loki, Tempo, and quite recently on OpenTelemetry. But nowadays, I'm doing rough screens because I am a new product manager, but I still am super plugged into the observability side of things. So yeah, that's why I'm here.
You went to the dark side. Hello, my name is Eric Chabel. I'm Director of Technical Marketing and Developer Advocacy at Chronosphere. It's a cloud-native observability platform. Yeah, and I think that fits pretty good with this panel, right? So, looking forward.
Thank you, Eric. Hello, I'm Petr Stívlo. I work for IBM as technical pre-sales. I've been working for observability recently, but I spent almost all my career life working for monitoring. So maybe we get to the distinction, what is the difference between monitoring and observability. Why I'm here? Well, that's exactly the reason. Thank you.
Thank you, all of you. So as you can see, like we have a really group of people who are part of different companies. So maybe the term observability can be different. And also like we have people in the audience who are new to it. So can some of you maybe give us some ground about what observability means and how it fits into the Kubernetes world? So we have like common ground for the discussion. Who would like to start?
I'll do the academic part. There is actually a definition here. So if you can look it up, I did that too. So it's not from the top of my head, but actually observability is defined in some way. I think it has been defined ex post after we have started using observability and people trying to find the right meaning. So that's my impression. But anyway, observability as a term, it's an ability to define or to come up with some insights or knowledge of a system, of a distributed application or cloud native application by analyzing the external outputs, external data, by means of some signals, right? And everybody has heard it many times over the last 2 days. There are some defined signals that we commonly agreed on, traces, metrics, logs, but there's also many other signals that have not made it to the observability definition. So those are less pronounced, such as profiles. There's also events. This is where I come from, event management. So event is not a log message. And there are some people that consider it also errors. I mean,
aggregation of errors.
Errors, when you're catching exceptions. Thanks for that. And there's actually a definition by the founder of Jaeger, Yuri Shura, who defined the term tempo. So traces, exceptions, metrics, profiles, logs, and events. Did I say events yet? And anyway, pass it on.
Thank you, Peter.
Okay. When you look at observability, I like to look at it across the generations of what's been going on in the monitoring spaces. Originally, we started out with server racks, data centers, and you were actually monitoring what a known environment, a known size, very very easy to target application layers and all this different stuff that you were doing, whether it's a system or not. You went to the second generation, you started getting VMs, and it gets a little bit more complicated. That's kind of when you saw everything you're seeing now around APM and those kind of monitoring platforms, looking at applications and stacks and messaging layers and things like that. And then you have the cloud native world where things are auto-scaling with Kubernetes and the data explosions that you're going to hear us talk about here today. And that requires a third generation of monitoring and observability. And that's what the cloud native observability platforms are that you're talking and hearing about today. They have to give the customers the ability to control the speed with which things are happening, the cost that's being generated, and give them insights into the data that they're using and not using to be able to deal with these environments, to survive in these environments, especially when you get successful and it all explodes in your face.
Yeah, I mean, you two answered it pretty concretely. I don't think I have anything extra to add. However...
Sorry about that.
No, it's a good problem to have. I have a lot of non-technical friends who call me up when their volume stops working in Windows, and I tell them to restart, and they ask me, what do you do? And I'm not going to show them graphs. But like I kind of explain that, I kind of help people understand what their code is doing, and this could be any code, and it could be any form of understanding. For example, people say logs, metrics, traces, but just errors and error aggregation is good enough, and it's observability. So yeah, anything that helps you understand the piece of code that you're writing is observability.
Mm-hmm.
I think that we have more types of the observability tools. So when I should somehow describe to my child what the observability is, so I just mentioned that you have the application when it should run in somewhere. So you should know how the application is behaving. Yeah. the behavior of the application, and not only the app, but also about the platform, about the network. So I have to collect some data about it. And also I'd like to somehow make some visualization of this data and also make some alert solution that I wanted to know that something is, I see different behavior of the trends in these metrics or logs. So it's just about the tools for getting these, we can call it metrics, and the way how we can store it there somewhere and how we can make some decision from them.
And Miro, do you want to add something? Or?
Well, on maybe two things that has been described pretty thoroughly, and I don't really have to add too much to it. There's one aspect that wasn't mentioned is that when you talk about observability, it's not only about the tools, because at the end there is some kind of notification. There is a Opus Genie notification there, or PagerDuty, or a Slack message or something, whatever you have. But there's also important, what do you do as a result? So there is this process part and the human part of the observability. At the end, the goal of the observability is an action. That doesn't make sense to get information which you don't act upon, most of the cases, and this is also important part of the observability. That's one comment that I would like to add. And maybe the other kind of comment is that equally important is what, in addition to the things that happened, are the things that don't happen, and that's a sign. This is something that usually happens, doesn't happen. It's this anecdote of the dog that was not barking, and then that was the clue in some detective story. And if you have data about your system, if you collect data over a period of time, you will get very valuable information, and based on this data, you can go into the path and see which things are supposed to be happening and are not, and that's important. And also, what are the trends? We work in the e-commerce space, and for us, the Black Friday time is very important time. And what we usually tend to do is to look at the metrics from the last year and see the trends and anticipate the load and make sure that we can meet the load or more for our clients. That this is also a side effect of the observability, learning from the data, not only directly acting on the data, but acting on the data in kind of a larger time horizon.
Thank you, Miro. You touched maybe on the next question a bit, because like for me, it's easier to understand when I hear some practical examples of how DevOps teams or SRE teams or whatever you call it nowadays use it. So can you give me some more practical examples of observability and how it is used?
Well, we use pretty much the standard tools. Then we use Prometheus on Kubernetes, we use Grafana, but we also still have some data centers from the past, which we are in process of migrating to cloud. Therefore, we inherited our own share of some older tools, and it's kind of challenging to streamline those data and make sure that the same process of handling these notifications can be used when it comes to cloud and the data center, because usually you have different teams involved and different kind of skill set required for dealing with it. So I don't think that my particular experience is very typical for if you are really living in the cloud, then the practical example is, well, pick something that is well aligned to your organizational structure, because you don't want to just install Prometheus that will generate like lots and lots of information, lots of alerts. You need also to define which of these are important and how are you going to handle them. What are you going to do as a result of these things? If you don't define that and if you don't clearly separate important things from unimportant things, you may not get the results that are expected, because the really important information will get drowned in the noise of those monitoring systems. Can tell you a lot, and they can sometimes tell you too much, and it's equally important as making sure you pick the important events is not to pick the events that are, for example, in Kubernetes, there are a lot of things that are self-healing. And you want to know about them, but you don't want to start a relatively expensive process of notifying and raising people during off hours just for something that you know from history that will correct within like 2 minutes or 1 minute. If it's still within the SLA, that's perfectly okay. If it doesn't fix, then you want to start the whole process. So that's...
Thank you. Eric?
Let's change the order up a little bit. Instead of talking about technology so much, which tends to get us all down into the weeds, basically what you're looking at with one of these use cases is you want to know what's going on as fast as possible. You prefer to be warned before it happens, but okay, maybe it happens and then you get warned, but you know as quickly as possible. You're not waiting for your visualization to load because there's so much back data and stuff piled up that you can't get your images in front of your face. You want to be able to triage this stuff as quickly as possible, whether that means remediate or whatever it's going to be. You want to be able to take action and take sensible action. And you want to be able to go back and understand really deeply what happened so it doesn't happen again. You can take measures. So we talk about know, triage, and understand. That's not logs, metrics, tracing. That's not digging down into Kubernetes pods and all this other kind of stuff. It doesn't matter where it came from, where that information presented itself, as long as you're able to corral it and use the information that's important to you to make decisions, and you're only paying for what you're using, then you're going to be a happy camper and you're going to have a really effective observability stack. It's something that people are struggling massively in the cloud to achieve.
Yep. For a practical example, how many of you have seen the architecture of Cortex or Mimir? Okay, it's like 9 or 10 different microservices. So I joined Grafana right after college, and I was supposed to do query optimizations on this massive beast, and I had no clue how everything worked together. And of course, I was working with the creator of Cortex at that point, so he used to hypothesize in his mind, and then he used to explain to me the hypothesis, and then he used to run the experiment, and I'm like, what the hell are you talking about? So I took some time to set up Jaeger and tracing, and that changed the whole view for me. For example, I could look at a slow query, get the trace ID, look at the trace, and I could understand, okay, it took 18 seconds because PromQL took 3 seconds. Because talking to S3 or Bigtable took 5 seconds. So it kind of helped me understand what was slow. I mean, I still couldn't optimize shit, but at least I understood what was slow and why things are working the way they are, what are all these components and how they work together. Yeah, so that's one practical example of observability for me as a new developer trying to understand a beast.
Okay, I can give you some examples of usage. So we can split it up to two things. One is the platform, and the second one is the app itself. So when we speak about the platform, so I'd like to get some, I'm running the Kubernetes cluster. So I wanted to get some metrics. So I can use, for example, Node exporter to get some metrics to the Prometheus. And then I also wanted to get some events and logs for the platform itself. And when we move to the application, so when I run the application, so I like to have some the application metrics. Like, for example, I wanted to know how many users are connected to my website, right? I also wanted to collect some logs. So I can use a solution like Loki, for example, or ElkStack to get the logs. Yeah. But there's also the second type of the logs, and there's the exceptions, right? So you wanted to know once there's something strange. So you can use solutions like, for example, Sentry to get these metrics and see some trends and set some alerts about it. Yeah. But when your application, sometimes there is no issue, I mean, from the logs perspective, but you can see that your application is slowing down. Yeah. So you wanted to know what's happening there. So the thing is that you like to get some traces. I mean, the analysis of the whole flow, what happens when you call, for example, exact endpoint. So you should have some tools like Jagger or Tempo to collect these metrics, but you have to also make them together. Yeah, because if you have only one of the type of these events, so it's useless. So you have to somehow make some visualization, for example, via Grafana, and then you have to set some alerting, and then you can use, for example, the alert manager from the Prometheus stack. But the last thing is that for these all solutions, you have to use a different tool, and it's quite common that you store it in different tools. So maybe you should realize that you like to have also high availability mode and also one store for all of these types. Yeah, because if we speak about the metrics and the Prometheus, so you can use tools like Thanos for the high availability mode. Yeah. But sometimes you have more data sources and you wanted to collect them. And for these cases, the Thanos is not good enough. So maybe you can look about the other tools like Mimir, for example. So yeah, there are so many tools. So I think that it's quite hard for guys to choose the right one.
Yes, Danik, you ended the question right away because I wanted to ask about this. So you all mentioned different tools within the CNCF landscape. There is thousands of them, and it's so difficult to figure out which to use. And maybe Eric mentioned that sometimes the technology is not something that you should put like front when you are implementing it. So what criteria the people should have when they are thinking about implementing it?
Happy to start that one. So one of the interesting things you're going to find out...
Sorry to interrupt you. I have one, I just look at the question and there is a follow-up question on this. How do you balance it between gaining observability and maintaining performance in Kubernetes? So that can be also mixed with that question. So, sorry, Eric.
What's the question again? Can I read it somewhere? The first one? What do you think about... Third. How do you balance between gaining observability and maintaining performance in Kubernetes?
Yeah. And Eric, you wanted...
So is that...
I didn't want to interrupt you. It's just that Eric, continue in the...
Okay, let me try. I know I'll give it a try. If it's wrong, somebody else will take over. But my understanding, if the question is right, and whoever raised the question, feel free to correct me. But if you mean, is observability, like the tooling, the instrumentation, slowing down basically Kubernetes, making it less performant? Is the question about how do we make? I came online. Okay. So anyway, if that's the question, I think it has been already asked in some previous sessions. It's really a matter of choice, like what you want to observe, and we can think of it as from many angles. But one first angle would be, don't overdo it. Like, there is no observability that will get you everything from a single source or a collect-all agent. There may be some efforts to do that. Even mentioning open telemetry, the ambition is really huge, like to provide a solution for all. But it will never be the case because yes, you will kill the system just by observing it. The right thing, I think the right approach, the reasonable approach, and this has been proved like in the history, you need to be selective at the beginning. What do you need? What are you interested to see? What's your business reason to do the observability? What are the outcomes that you want to get out of observability? And collect just the data that you need. Start low. Observe the system, how it performs. If you can do more, if you need more, raise your granularity and proceed gradually, simply. So otherwise, of course, there will not be, the observability itself. I mean, it can be a pretty intensive process. So be cautious on choosing the tooling and choosing the amount of data.
Miro?
If I may add, I would emphasize different aspect of that. It's not only performance. That performance is usually not a big deal. It's kind of a few percent of the whole output. It can get worse if you go overboard and try to post-process those things and aggregate and summarize and predict and do all kind of complicated processing on it. But the interesting things that I've noticed before we started to move towards the SaaS solution like Grafana, is that if you install in an empty Kubernetes cluster all those best practices tools, all the Grafana, Prometheus, Jaeger, and so on, all the Fluent, Beat, and all those things, then you end up with like 15 pods that are just for that purpose itself. And these pods they are not a big deal from a performance perspective. They are fairly lightweight, but they quite often are responsible for a lot of more observability noise. Kind of the observability system is observing itself and reporting on itself a lot, which actually defeats the purpose. You want to be notified first about the business loads, not about that this pod from observability cannot talk to that other pod from observability, which is usually self-corrects itself. So this is the kind of weird effect of if you put a lot of tooling in place, that tooling will keep itself busy for a considerable amount of time.
One more comment is like performance. I know it has been related to Kubernetes, but you can make it more generic. The thinking, like the performance is not just the performance of the system itself, but you can think of business performance. You can think costs. Those are things that you need to take into consideration, especially with tracing. I'm sure this is the case with metrics. Costs of storage are becoming, a differentiator at some point. If you just go crazy and collect all the data, you need to put it somewhere. And of course, this relates to performance after all. Yeah? If you don't have the money to buy expensive storage, your performance will not be good.
I also think that's a reason you're seeing quite a bit of the larger users of these kind of platforms outsourcing this to a SaaS provider, which is what we also do together with Grafana Labs does the same thing. There's a real reason for this. We did an observability report in 2023, and I mentioned this in my talk yesterday. There was some statistics in there that were pretty shocking, and one of the biggest ones is that when you're setting up your infrastructure and running a DevOps kind of organization in the cloud and dealing with all this cloud native complexity, and you start putting together your observability platform, and pretty soon that starts becoming not just a part-time job, but it becomes a full-time job. And your team starts spending more time not doing what they're supposed to be doing, but more time managing the infrastructure. And the SREs that put their hands up can tell you all about this. Becomes a full-time effort. And out of that research report, which I linked to in my presentation if you want to go back and look at it, one of the most shocking things for me is 25% of their time, these engineers, is being spent on issues and triaging problems. So if you're spending, 10 hours a week doing this, are you happy? Is that what you signed up for? Is that really what you enjoy doing? And really quickly, you see when it gets to be a large-scale operation. One of our customers, for example, during the pandemic, DoorDash, delivery of food, right? So when everybody got locked down in the pandemic, they started delivering food like crazy. And this scaled up so fast and so hard that it became more than a full-time job, right? You need to outsource that kind of infrastructure and get back to doing your core business to make the money where you want to make it. And getting people off of 10 hours a week of triaging issues, and which leads to nothing more than a bunch of statistics about burnout and why people don't want to work there anymore. And this is not how you want to live your life. This is not how you want to retain your talent. And your talent you actually hired for something else, probably, right?
There was another interesting statistic in his talk. It's quite common that the cost of observability is more than the cost of infrastructure. So I have a question for you. How much do you think observability should cost? So if you're paying $1,000 for infrastructure, how much are you okay paying for observability? Is it $5? Is it $500? Is it $5,000? Yeah.
No.
In the end, it comes down to the business question. You first need to understand, okay, what are the questions I would like to ask, and how quickly do I need them answered? And some people would be like, I need to answer all the questions in a millisecond. And that comes with the business trade-off that this is going to be ridiculously expensive. So you need to kind of while choosing the tools, while choosing the providers and stuff, you need to understand, okay, I'm okay if I'm only able to answer these set of questions within 5 seconds, something like that. Like, it's okay if I see only 5% of my traces. And at that point, you'll be like, okay, 5% of traces cost me 50% of my observability toolset, and 50% of my infrastructure, and 1% of the traces cost me 10%. I'll probably go for 1%. Like, it's a business to value question when you're picking tools, and that's kind of how I would evaluate. Like, do I really need eBPF profiles? Probably not. Would it be good to have? Definitely. Would I pay for them? No. And it's questions like this when you're picking tools. Yeah.
Okay, and are there any other challenges with implementing it or not? Like different observability tools?
Yes, there's always challenges. You could always be too good and write a bunch of alerts, and then your developers are getting paged all the time. That's a very, very common challenge. Too many alerts, and then you black hole all of them with an email filter, and then you sleep peacefully through the night. Your customers don't, but that's a different story. Yeah, the two challenges I see with implementing observability, three, I would say, is one, cost. The second one is too many alerts. That way, alerts lose meaning. And the third challenge is not enough visibility, which means there are issues happening and you have no idea. How do you solve those? I don't know. If somebody can solve those, I think they will be really, really good at their job. Yeah.
Yep.
Just to add to that, the cost of storing data, it's important things, but especially with traces, there is this retention window that's kind of important. You don't really need traces except when you need them as a result of some event. It's like the rule that five hours before each fire, the fire department needs to inspect the state of those machines and so on. So essentially, you need to establish reasonable trade-off between the cost you are going to invest on an ongoing basis and how much you aggregate this information. There is one window where you want to keep the traces, all of them, for a certain amount of days, and that's after the new release. Because when you are releasing new version of the software, it doesn't have to be a problem with your software. It can be a problem with interaction with environment, with some hidden assumption. And in these cases, the traces are absolutely priceless. So this can mean days in terms of being able to react quickly and fix the issue. That's the.
There's a really practical example of what you might consider. It is a public case. I'm not going to mention the company name. You can go figure it out for yourself. But there was a CEO reporting his observability numbers and stuff at the end of the year, or at the end of the quarter. And it turns out one of the customers they had on this observability platform spent $65 million with them.
In 1 year.
In 1 year, right? $65 million. I mean, that should blow your mind, right? And it pretty much caught everybody's attention in the press corps too, right? So follow up and everything on that, and somebody just uncovered, I think it was last week, sent out the debug report on this, and it turns out it was a Bitcoin company. So that's like really rich people digging into their pocket, and what do they pull out is not the same amount of change I pull out of my pocket, right? And for them, 65 million at the time was definitely pocket change. You know, they were making oodles and oodles more than that, so they didn't really care. And that goes around back to what he was saying. Observability costs, tooling, all the stuff you're using, nobody's going to care at all if you're making money, if customers are having good experience, if you're getting done what you want to get done, and everybody's able to discover where the problems are and fix them in time, right? We will pay anything. It's like Super Bowl ads. Why do people pay that much money for 30 seconds on TV? Because it achieves what they want to achieve. They don't care what it costs. The people that advertise it just don't care, right? They can afford that. This is the problem with when you look at this space, you can easily get just swamped with what happens in the bill, where it just surpasses everything you're doing normally in your business. But if that's acceptable to you, fine. Nobody's going to make a noise or make a problem out of this or change anything that they're doing. But as soon as you stop making enough money on this side, then this is going to become a huge problem, right? And that's going to be the first thing they start looking at. I mean, it's full stop. I think it was there was a pretty neat statistic last year, right towards the end, where I was watching a cloud report, and an analyst was talking about how in their research they found out that 83% of, I think it was 83%, maybe it's give or take a few percent, but it was in the 80s, organizations would have a financial operations, a FinOps position by the end of 2023. And that's pretty crazy, right? They can't figure out. The bottom line is basically your CIO, I think, owns, or your CTO owns the budget, right? That's the end responsibility for what you're doing with your platforms. The problem is you have developers sneaking stuff in, you have engineers sneaking stuff in, and nobody really knows who pushed that button in that cloud provider's marketplace to add this new load balancer that's now adding tags and metric cardinality that's just blowing up your budget, right? You need to have a position that fills that space, that quantifies what's going on, puts processes in place, all that kind of stuff. Apparently, within the next couple of months, everybody's going to have one in Europe anyway. So would you interested in that kind of a role, where you could be responsible for every penny that gets sent down the pipeline for observability?
Anybody?
Yeah, I see two big challenges. First is that you have to know why and what you wanted to collect. Yeah, because what I see in many companies that they collect a lot of data and they don't use most of them. I mean, never. Yeah. And the second thing is how long you wanted to store them. Yeah, because so many companies tries to keep their logs for almost a year. But just realize that last time when you look at the more than maybe 1 month older logs, yeah. So why are you storing them? So you pay so lot, and you have to find different tooling, because once you have these logs, so it's quite hard to find them because it takes time. So maybe the challenge is to find some agreement, I mean, with the developers and the management about it, what and why are you storing this data. Yeah. The second challenge is we have a lot of tools for, making the observability, but still it's quite hard to put that together. Yeah. So you can collect logs, metrics, traces, but there is no easy way how you can see on the one panel all these data, and you can easily to find the root cause of the issue. So yeah, there are some solutions like the OpenTelemetry, for example, right now, which tries to move the stuff like this, but we are not still there, and we have to find the solution for it.
And I will pick one question from the slide, because it might be related. Have you ever encountered something similar like happened to Datadog with massive outage? Can you blame observability or process behind them in such case?
My answer is happy no.
Anybody else? Yep.
So I think you're referring to the recent Datadog outage where they deployed systemd, it broke Cilium, and that broke Datadog for quite a long time. Is that it?
CVE, I think, yeah.
Yeah. Can we blame observability? I hope not, because, but it's typically process, I would say. For example, in Kubernetes, we had a big outage where all our pods were suddenly being killed by Kubernetes and nobody could figure out why for a long time. And it turns out we configured health checks, but we never activated the health check in the application. So Kubernetes was thinking this pod was unhealthy and it was killing it regularly. Yeah, like we kind of weren't prepared for that. We didn't know what a health check was properly going to do, and we enabled it on all our applications. I would more call it a process and testing failure rather than blaming something like observability for it. And I think observability helped us fix it in the first place. Yeah.
This is probably not going to age well, but right now I can say that Chronosphere has been able to keep 3 nines historically of uptime for the history of the company so far. That's not an easy thing to do. That requires quite a few things to happen, and to be really good at what you're doing. I don't think it's fair to really pick on that specific outage, especially since the complete report hasn't been put out about the incident. They put something out, but not all of it yet. So you kind of want to wait and find out exactly what happened. And I mean, those are the most interesting things to read, right? Because everybody can learn from those things. So we hope everybody's going to be open and honest about what happened. That's what you're looking for. And I think it's something seriously to evaluate when you look at companies that are providing these kind of services for you. How do they handle this stuff in the past? How open are they with you? Or do they just do that with select customers? Do you have to have a certain tier before you get good response times and things like that? I think that's super important. So I don't think it's fair to pick on a specific thing like that, and you can't just point to a specific cause or a specific reason, usually.
Just on that, of course, I don't have an example because I work for IBM. It doesn't happen to IBM. No, but seriously, I think this is referring to the point that we heard in the beginning. There's a lot of things that we don't learn, that we don't know from the press because of observability. How many incidents have been avoided by thanks to having right tools, right processes, right observability in place. You will never hear the good news. This is actually no news. I mean, you will not hear it in the news, right? Nobody writes about things, but those are really the stories that we should hear. Like how many things they managed to avoid. This is a singleton. This is a disaster that happens to everybody. This will happen to everyone. And yeah, it's very sticky with the press.
Yeah. So I will pick up on some of the questions from the audience because they are really active, as you can see in the Slido. And there are 2 questions related to machine learning and AI. Do you use some kind of machine learning with metrics?
I do not.
We do have some machine learning, but we try to not make it automatic. Like we do have a product where you can say, hey, run these algorithms on these metrics and kind of show the trends, and then you can alert on the trends and the deviations from the trends. But we try to make this manual so that developers think and know what they're doing when they set up that alert. I think it's really hard for machine learning to get all the edge cases correctly, and you might end up in a case, it's very common that you miss the important alerts or you get a lot of alerts, so you black hole everything and then you miss everything. So yeah, we do some machine learning, but we haven't found like a magic bullet. I don't think it's possible to find a magic bullet with our complicated architectures and applications. So if you're doing machine learning, that's a good thing, but think about what you want to achieve and then use machine learning to achieve that instead of being like, hey, AI, just alert on anomalies that you think are anomalies. That will just end badly.
Yeah, well, we do have a tool in our portfolio. I don't want to talk about that tool, but yeah, I think this is really the future that we are going to look at in observability, the machine learning. Some call it AI, because this is really about searching the needle in the haystack. You cannot really pick everything from the screens, no matter how well consolidated, how well correlated the stuff is. Simply, there's so many things happening, and there's so many symptoms associated with a single failure. So the root cause is perhaps one, but there's lots of indicators on that. So we definitely need some AI, some machine learning. I agree, it is a complex area. We do have solutions for machine learning, on logs, also on metrics, but this is pretty hard. Yeah, this is really rocket science almost, and yeah, and it depends on the customer, their use cases. So no matter, we may develop, we do have generic models for many typical scenarios, typical situations, but still you will have lots of customer-specific cases. So basically, I think we are looking at some tooling that will provide some general-purpose AI machinery that will sit on top of the observability tools or platforms. Maybe that's the future.
If I may, I'm not an AI expert, but we are having these active discussions on this theme about how to connect these areas. And we see a couple of challenges, and one of the challenges is the problem of training. So you can have enough training data from the system you are running, but that data needs to be you need to create a trained model, and in order for the model to be good, you need to look back on certain amount of time. So therefore, that means that you need to train that with the data that are going long back in the history, which means you are supposed to be spending a lot of money on that training, and it's kind of hard to justify the expense of running the continuous trainings, potentially very expensive big machines, versus the assumed benefit of the thing. So it is kind of, I would say that at this stage, it is excellent solution looking for a good problem. So,
I also just want to add to his point. I think there's a lot of value AI can add. I just wouldn't run your primary alerting on top of AI. I would still run primary alerting on top of SLOs, and once you get alerted, then maybe you can look at AI for possible causes to this. That can maybe then start to, okay, what is the anomaly compared to last week, and why did this alert fire? That could be something that's useful. And you might not even need AI, but it could look AI like, for example, all you need is like a history of all the alerts that fired, all the incidents that happened, and when an alert fires, you could basically look through that history and be like, the last time this alert fired, these incidents were declared, and these were the root causes. Can you check these? That is also AI for most companies. Yeah, you don't need AI, but like you can get a lot of things without AI, but do not run primary alerting on top of AI, please. It just sets you up for failure, yeah.
I just have one observation that since I started university way back in the late 90s, they were promising us that AI was going to be solving all the medical systems and automating all this stuff. And what's the biggest innovation that we are hearing about right now? It's just ChatGPT, you know? That's all I'm going to say about that.
Okay, thank you. And another one we have, how do you handle FinOps?
Well, I touched a little bit on it with a stat, but there's quite a bit of stuff that's come out in the last 6 months around this, and there are organizations you can find online, like LinkedIn and stuff, that have FinOps, like practices and things like that. I know in North America they're quite heavy in that. I was reading an article yesterday about someone that was interacting with Google and just launched something around some FinOps programs. So you would be pretty hard-pressed not to be able to find enough information if you dig around online a little bit about this, and maybe join one of the local meetups, if possible, in your area.
At Grafana, we do have like a cost optimization team, which is similar to FinOps. And we're just building on top of open source tooling out there. So there's OpenCost, which is a CNCF project. You deploy it onto Kubernetes, and it'll tell you this namespace is costing you these many dollars. And that's pretty good already. And it'll tell you this is the amount of utilization that you're running at, 80% CPU and things like that. But yeah, I would, we are handling it by having a FinOps team and using open source projects.
Just a quick one. Well, in a similar way, we also have attempts in this area to optimize the costs, either on-premise or in the cloud. But I think there's an important connection to observability, and it's the term that is sometimes used. It's right sizing. So you can definitely leverage observability to give you the inputs to correctly size your infrastructure, your virtual machines, your pods, your Kubernetes clusters, etc., because you probably know it better than me. And that it's always a problem to size the cluster, to size the pods right. You never know upfront in advance what will be the correct sizing. So observability, there's a very, very tight connection to the FinOps aspect of it, like managing costs by right-sizing the workloads so that you don't overdo it and also don't, underdo it so that you have underperformance. So you don't want to spend more than you have to.
For FinOps, it depends what you wanted to calculate it. If it's the spend of the cloud, about the network, about the Kubernetes, yeah, because there are some solutions for the Kubernetes, so it was mentioned, the OpenCost. There are also some, if you are using the managed Kubernetes cluster, so there are some solutions, for example, by the Google. Yeah, and it works somehow good, except PVCs, of course. But it's not just about the Kubernetes, yeah, because you wanted to calculate the whole infrastructure and also maybe split it by the application. But sometimes it's if we are in the Kubernetes space, right? So the application doesn't mean that it's run on the one namespace. So how you will calculate it? Because these tools are based, for example, by the namespace or some tags, right? So yeah, the current solution, they are not, I think, final. I hope so, because we miss there a lot of information. Yeah. But when we speak about the cloud solution, I think that it's provided by your cloud provider.
I'm not directly involved with that group, but what I know is that we are using predominantly the SaaS solution and the partner solutions for that, something like Cloud Checker that gives you information about which parts of the which accounts are underutilized, and also now the Kubernetes is deploying some solutions. They're using Spot, which is essentially trying to utilize the Spot capacity of Amazon Cloud. These are the two that run on the top of my mind. But generally, if you are running Kubernetes in a multi-tenant mode, then cost distribution is a non-trivial problem, because if you have everything split by the namespaces, then it's relatively easy. Most of the tool gives you cost allocation based on namespaces. But if you are sharing infrastructure for multiple tenants, then it is not an obvious which portion of the cost belongs to whom. Obviously, you could run one Kubernetes cluster per customer, or even one Amazon account per customer, which makes it extremely easy to calculate, but it's not the most efficient way how to do things.
And you started to mentioning some tools, so I will also grab the question about that. Like how important is having like really unified view when it comes to observability, and what tools you can use?
We actually have a talk that we shared. It's called Single Pane of Glass, and they spell pane P-A-I-N, right? I think when you look at an organization, the complexities that you're dealing with across the organization, depending upon who you ask in your organization, what's important to them, is pretty much representative of the view they want to have of what's happening with the business, right? And so I think a single pane of glass is a complete fantasy. I don't think it's ever been successful anywhere. I don't think it's ever stayed with just one view. I'm not saying you don't have that single top tier, whatever you try to look at your business with big green, red, and yellow boxes, but it's pretty much a sad attempt at saying what the status of the business is at that moment. It requires all these different layers for a reason, and there's nothing wrong with that. Do you agree?
Yeah, no, that's a good question. So before I get into the tool, I kind of want to go back to the story I told about traces and how I implemented traces. This was before Loki was there, before Grafana did logging or tracing. So the way we did this is basically take all the Kubernetes logs, pipe them into a file, run a script which gets the trace IDs and the slow queries and all of that into a Google spreadsheet, and then sort the Google spreadsheet by the slowest queries, and then look at the trace IDs and then open them in Jaeger UI. Now you can imagine how painful that was, but before that we had nothing, so that was the greatest thing I could have built as a junior engineer, and people loved me for it. Now, like again, this is how we kind of learned, okay, people want metrics to logs to traces in the same, in an easy way to jump between the three, because they give you three different kinds of insights that you will be using together to solve problems. And there are many tools that kind of give all that insights in one place. Like if you take Datadog or New Relic and other observability SaaS vendors, all of them are in the same place, and you are able to jump from A to B to C. And I think that's quite important. You can obviously, if you want to do it with open source, you can do that with Grafana. And this is also something that we are seeing, as Eric said, like if you take a large organization, it's really hard to get all the data in one place. There will be 5 different monitoring vendors, 5 different logging vendors, and trying to get them into the same place is really hard. And trying to do that longer term, you can do that with Grafana, but you wouldn't be too successful, because when you're trying to interact with Splunk data, the best place to interact with Splunk data is the Splunk UI. You can put Splunk data in Grafana, and it will give you a beautiful view. But the moment you try to deep dive and debug, the powerfulness kind of reduces. And that's for a lot of people, that's still better than the workflow that I had, which is like, you go from here to another tool, to another tool, to another tool, and it takes me 20 minutes to get the insights versus the 5 minutes. So it's a question of trade-off of how much power you want, versus how quickly you want to get from tool A to tool B. Yeah.
Again, a quick one for me. I agree. Everything, screens are important, and I think this is also a place for the future consolidation of the tools. So again, if you are talking about the future of observability, this is the area that will take place inevitably. Another comment regarding the availability of data. I think it's really crucial. You can have good screens, but is it really that you're looking at the screens all the time? Wouldn't you rather prefer to have the right information at the right time, where you need it, at the right context? So first thing, I think users will appreciate tools that give them the context at not necessarily by looking at graph, but maybe clicking in the right place in the graph, topology, showing things in context, and clicking drilling down in a connected way. That's one thing. Another perspective here is that there are alternative ways to screens. For example, there's a concept of so-called chat ops. I don't know if you're familiar with that, but some people, who are crazy about chat platforms like internal Slack, if you're heavily committed to this, if you use it internally, it may be a good idea to connect your observability tools to Slack and have the insights being presented to you as Slack messages with all the insights, with all the correlated content available there as the first contact for you, and then you can extend your analysis to getting to the full-blown dashboards or to the screens.
If I may add, I wouldn't see it as having unified view from an operations perspective, because if the action of the result of having that view is actionability, then with a large enough organization, you have always different teams for different systems with different skills, and the team that is managing your Azure cloud doesn't actually care about any alerts from Amazon and vice versa. So this is just distraction for them. So having unified view is actually worse. What you may want as a unified are some sort of reports for the decision makers that are not essentially to be doing something about that result, but using that data in order to plan and in order to make a decision, so for like decision support system. And in this case, it's important to have unified view, but it can be done significantly cheaper and significantly less obtrusive way as to force the whole organization to use the same tool chain just in order to have one unified view of the data.
No. What's quite common is that if you force more departments to use one tool, so they try to modify it for themselves, in a bad way. I saw it so many times. So the thing is that one way is just force them to use some SaaS solution like Datadog, New Relic, and stuff like that. I have some experience with that, and I understand that it's useful for someone. But when you wanted to do this, modification, so maybe you realize that it's not the way. Yeah. Another thing is that the vendor lock is also not the best way. So it's much easier to use, to choose some tools from the CNCF landscape and try to connect them somehow, because there are more solutions how you can do that. So.
And when you mentioned the bad ways using it, so can you maybe tell us more of this? Maybe we can learn even from the not best practices, but what went wrong and how we can learn from it.
Oh, you just teed that one up. So what would be bad practices? We've already pointed out putting in ML and AI up front. Trying to put a unified view in place. What else would be good? Choosing as many tools as you can come up with that they'll let you buy. No, but all the joking aside, I think the worst practices that are going on right now, and what people fail to understand, is the amount of data that is flooding into your organizations, being collected, it's being stored, is what's running those costs up, right? We've already covered that. But being able to find a way to corral that is immensely difficult. In organizations that have gone down different paths, like we've been talking about, you may end up having one or two of those problems in your org right now. What you're looking for is some kind of control plane between you and what's coming in before it gets persisted, so that you can see what's not being touched, what's not being looked at by a user, which is not being used in a dashboard, which is not being used in an ad hoc query, which has absolutely no impact on anything you're doing at this moment in the company. Those kind of things you want to be able to block at the door. And you're not getting rid of them. You're not, throwing them on the floor. You're just not using them right now. And you can flip the switch and turn that back on later if you need them in a new project and define that I need those labels or I want these metrics or whatever the deal is. The second thing is, I think it's really important not to get too fixated on tools and all this other stuff. It's mostly about trying to figure out what your business is doing. When you design your visualization, whoever's the business behind you having to design that visualization to keep track of what they're doing, they know best what they want and what they need. You just have to have the ability to narrow down and only use what they need, and not pay for one penny more or one label more or one sub-dimension more of any of your metrics. Right? That's such a strict policy. You need to get set up as soon as you can, because it'll snowball out of control in no time, and it just gets exponentially worse when you get successful in a cloud native space.
one example from my experience. Things that can go wrong is, an example one is a customer who has a lot of legacy. So it's about the right tool for the for the right software for the right system. So yeah, I think it's wrong if you approach to replace an existing monitoring solution which has been working for you for ages with some sexy new observability platform which does tracing all the metrics, and actually basically have to force the customer to redo all their or all the setup in order to be able to consume Prometheus metrics and so on. So I've seen enough such attempts. I can't say really that I've seen like disasters happening. I think that it didn't actually come to the disaster level yet, but I have seen so many attempts trying to force potential customers to new tools that they are not ready for.
I would add to these not so brilliant ideas. Kind of one idea is to using multiple delivery channels for notification. Like you post message into multiple Slack channels and send an Ops Genie notification and an email just in case, which will essentially make sure that your team will be dealing with the same thing 3 or more times and lose a lot of times. This is kind of one of those ideas. The other is that you define very loose response groups or escalation levels, which means that everybody knows that everybody else has also got this notification and everybody assumes that somebody will take care of it. So in which case you will end up with much longer response time, as if you know that, well, it is my responsibility today, and if the next escalation is this guy, and that this way things will happen. But if there is a large group supposed to be taking, then it either generates a lot of unnecessary communication, who is taking care of that using a different channel, or just people just assume, okay, somebody will take care of that. That's the...
I see two of them. First is sending too much alerts. That it happened that the developers and also ops team just stop focusing on it. Yeah. Because they realize that, okay, there is something, I know it, and it's quite common. So, and the second thing is what I mentioned in the beginning of the talk is storing data which you never used, and also store precision of the data which is not necessary. For example, if you collect every second, the metrics, so maybe it doesn't make sense for all of your metrics. So you just pay for storage what you never used.
A couple of things that I see in large organizations is like centralized firefighting teams. So you write an alert, but the alert gets routed to a central team, and then they triage it, and then they assign it to the right team. That is just a bad position to be in, but it's also quite common. This is what SRE teams are there for in some companies. The other issues I see is you have the data, but you don't have access to the data. For example, you could be on call, and your data could be in Splunk, but you don't have access to Splunk. You need to talk to a different team to get access to Splunk for an hour, and this is also quite common. So just make sure if you write an alert, it gets to you and not someone else. And if you're on call, if you're collecting data, you have access to the data at the right time, at the right place. Yeah.
That just triggered something really quickly I wanted to mention too that I saw last that I was pretty impressed with when I saw it was designing dashboards to include all the links and help and stuff you need from that point. So no matter how experienced you are, you're being led down the same path as an experienced person would do. So that's part of the understanding what happened last time and then putting something together that's available to immediately deal with the same problem again. And I thought that was pretty neat when I saw that all integrated into the dashboards they're monitoring anyway. It's really a nice touch.
And I will go to one more question, and then we will need to finish. So Alexei is asking, is it reasonable to set up traces for the monolith?
Yes, it's called an APM. This is like before distributed systems, cloud native, whatever, tracing existed in the form of APM. It traces like all the important function calls, how long a request took in each function call, and I think that's highly useful information. If a request is taking 5 seconds, you want to know where are these 5 seconds happening, and I think traces are a really, really good way of answering that. And yeah, it's quite useful.
And to understand that, it sounds like somebody might not have fully understood the difference between a monolith and a cloud-native environment where people took old monoliths and broke them up into microservices, so a bunch of little services, where then when we talk about tracing, it makes a lot of sense because a call goes off into the wild and we don't know where it went. And the next time you do the call, it takes a completely different path through that sea of microservices. So finding out what went wrong and why it went wrong and where it went wrong becomes really, really important in those spaces. Whereas in APM, like he's saying, it's more function inside of the programming language classes. You kind of it's almost like debugging in your IDE, I would say, but then live.
Oh, yeah, profiling, yeah.
Yeah.
On a per request level.
I wanted to mention
There is also one aspect of monolith that, okay, let's assume that your traces will reveal something. Now, for you, in order to fix it in code, means to do a full release. Which with the microservices, you can do this kind of, you replace just one microservice and there is much less disturbance. So essentially, your ability to act upon discovery of something important is very different from the microservices. So I would say it is also important to put traces around the monolith, because quite often the situation is not that the monolith has a problem, but something that is around it, something in the environment changed, and suddenly the communication doesn't work. And if you are putting traces around on all the endpoints that the monolith talks to, you may find out that all you have to do is just simply to restart restart one of the services, and you are fine. So it's a slightly different situation to the cloud native, but yeah, I agree what was said on that.
And exactly for strict monoliths, like a single binary, we have profiles, right? That's the analogy for traces, profiles and stack traces. One thing regarding microservices, and tracing that we see today, there have been architectures before, and I think we still call them monoliths. Those were called in the past like distributed architectures, like SOA, service-oriented architectures. I think they still qualify as monolith in a way. And what I want to say is that there was tracing before. We didn't call it tracing. We call it distributed monitoring, which evolved into tracing that we know today. So this is not a new concept. So if you have in mind like those classical three-tier architectures and some service bus around, all the legacy stuff, there has been tracing before, only a little bit, a little bit more difficult to work with.
Yeah, I just wanted to mention that if you like syscalls, so of course you can use some solution for continuous profiling, like Porco, I think it's in CNCF landscape. But yeah, maybe you are the lucky one if you can read it, I mean, from the developer's perspective.
Andrew Tannenbaum, he's an author of those famous operating system textbook and the author of Minix that inspired Linux and so on. It's it was one of the celebrities when I was going to university. He once said the definition of the truly distributed system is that is the system where a failure of a component that you didn't know it existed can cause the non-functioning of the whole system.
Thank you all. And we are running quite out of time. So I would like to just wrap up the discussion maybe with one question. Where do you see the future of observability and some kind of emerging trends and technologies in the future?
I will be quick. I hope that in future there will be something like no ops. That, I hope that one day there will be AI that will, can handle more of the stuff. I don't think so. I mean, in the near future, but I hope that it's the future.
ChatGPT. No, just kidding. Again, I agree with the no-ops stuff. With eBPF, it's super promising. Like you just focus on your business logic and you drop an agent in the kernel and you get full insights into your application at the granularity that you want without affecting performance. I think that's utopia. And I think we're very, very close to that. Yeah.
GPT or AI ops, AI-enabled monitoring. This is the future for sure. I think we haven't mentioned the aspect of security. I think this is becoming even more relevant recently. So security should be really a dimension in the whole observability discussion. So maybe a topic for next time.
I really don't have anything more to add, and I can say that I certainly hope it will be somebody else's problem, and that observability and all those SRE will go the way how serverless was kind of continuation of the classic servers. So essentially something that scales on its own, runs on its own, and it's essentially no ops, as Zdeněk said.
And I think it's a little bit more positive than that. I think the future is now. I think these third generation parties that are outsourcing the observability into the cloud and having the ability to put some kind of control plane between you and your ingested data and give you control back and give you the chance to decide what's important to you and you to decide how to limit your bill is just fundamentally more important right now to everybody. Than all these other little things coming down the road in the research spaces. I think you're going to see a lot more interest in these kind of solutions and these kind of takes on observability, giving you the control over your own environment. And thank you very much.
Thank you, everyone. It was a great panel. Thank you for all the questions from the audience. You were very engaging and helped me with running the discussion. And I hope that you will continue in it after this session, as we will have a coffee break, and you can get together with the speakers and ask them some follow-up questions. So thank you so much, and thank you all.
Really?
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
stealthier,
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations. Oh my God. Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks,
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves.
what security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, Appleware, and container granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Hello, good. So, welcome to the next session. This is the last ordinary session of the day, and afterwards we have lightning talks. The title of the session is Service Discovery in a Mixed VM and Kubernetes-based Environments Using Console. And our speaker is Tomáš Boroš from MedMe Technologies.
Hello? Okay, cool. Thank you very much. So my name is Tomáš. Today I'm going to talk about our journey, how we managed to migrate huge workloads from a VM-based environment to Kubernetes. And I also would like to talk about how Console helped us to solve our challenges which we faced along this migration. First, let me tell you something about myself. I'm a sysadmin and a DevOps engineer. I did my PhD at this university, actually. And while I was doing my PhD, I also had a chance to live in the Netherlands. And I did some research on the 5G core, on media delivery with MPEG and MPEG-Dash on dynamic adaptive streaming, and also a little bit some research on content delivery networks. And at the moment, I'm working as a contractor for MedMe Technologies. The company is based in Dublin, in Ireland. I work fully remote. And at the same time, I'm also a consultant for Slovak Telekom and T-Mobile Czech Republic. And for them, I'm helping to manage and maintain their content delivery network on which the Magio Go is running. Just a nice little side note that currently the Magio Go is reaching almost a terabit in prime time, so it's quite growing quite big. But yes, today I'm going to talk about a little bit about what we did at MedMe Technologies. So MedMe Technologies is a software company that is providing a digital customer engagement and customer experience platform. Just to be clear, what is it? So what they do, they are building software for telco operators, and we are helping those telco operators to reach their customers using advertisement and some campaigns. And yeah, we are helping basically reach the right audience within these telco operators. So I joined MedMe beginning of the last year. And my main goal basically was to move the workloads from virtual machines to Kubernetes. MedMe at the time was running on about more than 30 microservices. Those services were running on virtual machines, and all the virtual machines were provisioned with Chef. It was running pretty fine until something bad until something was going wrong. Since I was quite new in the company and I had not that many insights about the setup of other deployments and where individual services are running, for me personally, it was really hard. It was really hard to trace back any issues in the network or any issues in the service. So at that time, the only single source of truth was basically Chef. So let's say an identity service went down on the deployment. For me, it was really hard to trace back, like where that VM or where the service on which VM is running. So we kind of knew that we're going to need to improve this as well before we start the migration process. So the obvious choice was Kubernetes, of course. And since we have quite a huge deployments, so one of our largest customer currently is Jio India, and we run a sharded deployment for them, and that deployment is running on over 500 VMs. So it was obvious that the migration won't happen from one day to another. So we knew that there will be a huge transition period which at this point we're going to have services running in VMs and also in Kubernetes as well. So we knew that we're going to need a service discovery. Lucky thing is that service discovery sort of mechanism is supported by most of the public and private clouds. So Azure, OpenStack, VMware, they all have one. The problem is our customers, when we are hosting the solution for the customer, we mostly host it on Azure, but unfortunately, we also have some customers who prefer to have their deployments on-premise, and they don't necessarily use Azure, but they might be using OpenStack on VMware. So we were looking for a solution that could fit all these environments. So yes, we started looking into options. So we all knew that Kubernetes does have a service discovery mechanism built in. It's using core DNS. So the core DNS inside this Kubernetes cluster has a Kubernetes plugin that connects to the Kubernetes API and pulls basically all the services and all the pod and all the definitions and provides a DNS endpoint to the cluster using which you can very easily target individual deployments and pods. So let's say if you have a service running called identity in namespace Q&A, then you can simply find this endpoint on the domain name identity.qna.svc.cluster.local if you have if you're using the default domain name, that's what Kubernetes is using, or you can use whatever domain name you configure. But unfortunately, so this is working great. So even if you scale up or scale down the deployment, you will always use the same identity, so you won't have to do any modifications to the applications that are talking with this service. Unfortunately, such service discovery is not present for virtual machines, so we needed to implement or deploy something that was out there. So we started looking into options, what we could deploy, and basically we came across Consul, and yeah, we gave it a try, why not? So we tested it, we installed it on a few VMs, we installed the server layer in Kubernetes already, and basically we registered some services, and we just found out that it basically works brilliantly, and it more or less covered all the use cases we needed from a service discovery, from the service discovery protocol. And yes, we never really considered any alternatives since we didn't really need it to consider. Okay, so how did we deploy Consul? You have to deploy at least 3 servers of Consul. So Consul consists of two different components. One of them is the server layer, basically that stores the information. It has a persistent data as well, and you can install as many Consul agents running as clients, as many as you want, and you can join them together. So in order to achieve high availability, you need to deploy at least 3 Consul nodes. And the Consul server is using Raft protocol to achieve consensus. So, and then you can deploy an unlimited number of Consul clients that you can join into this cluster. And this cluster is using Surf protocol for information propagation, as doing in a gossip way. So the server part is strongly consistent. That means each and every read from whichever node is always basically up to date. So the database is consistent across all the Consul servers. There can be some slight little inconsistencies in case there is a leader election going on, for instance, but it's very, very unlikely. It only happens when something goes wrong in the network, for instance. And the clients are basically eventually consistent. So imagine one of those agents that's running on a VM starts up, registers a service, and then once the service is registered, this information is propagated to a set of nodes into network, and that set of nodes propagates this information to another set of nodes, and so on, until the information is propagated through the whole Consul cluster. That's why it's eventual, but actually it's really, really fast. So I included the URL on the bottom. Well, you should check it out. It's an article from Consul, from HashiCorp itself. And they were testing how fast this protocol is on a huge scale. So they were trying to measure how fast they were managed to propagate some information using Consul over 10,000 nodes. And so they were able to propagate the information throughout this cluster always under 1 second, so which is, I think, quite brilliant for that scale. Okay, so how does it work? Consul basically is a service discovery. I mean, Consul has more features than that. Today I'm talking most about the service discovery. It has two endpoints that are actively used. It has an HTTP API and also a DNS endpoint. It also has a gRPC endpoint, but this is not really enabled default, and we were not using that either. And how does it work? You basically start an agent, and you can register a service to this agent. You can define that service using an HTTP API, or you can define the service using a configuration file, either in JSON or HCL. That's a kind of a configuration language by console. Yeah, this is how does it look like. So you have the server layer up and running in a Kubernetes cluster, and what we did, we basically installed this console agent on each and every VM that we're running inside the same network. And once the agent is connected to the console cluster, it can start registering services. So for instance, there is a PostgreSQL VM running, which is registering the PostgreSQL service. Once it's registered, this information is propagated, and at this point, this service basically becomes discoverable by the rest of the network. On the right side, you can see an example how this service definition looks like. So it's very, very simple. You just define an ID, a name, and you have to define the port on which this service is running, and you can add some tags or metadata. You don't necessarily have to, but yes, you can include some. And on the left side, there is this console UI. And this is, once you do that, you can see that there is a service registered, and that service is currently running on node azure.qa.db.sh0101, and the service name is Postgres main master. So, oops, sorry. Okay, so once you have that, at this point, this service becomes available for the rest of the this DNS endpoint becomes available for the rest of the network. So you can query this service by the node name or by the service name .service.domain. So I'm going to show you a really quick demo. How does it look like? For our configuration, you can choose what domain you want to use for this console setup. In our case, we are using the domain name .madme, as it was an internal network. So let me open the console UI. This is how does it look like. So this is the server I mentioned that is registered with the console cluster. And if you click on the service instances, you will see all the services that are registered with this node. And this is the database, the Postgres SQL service that I mentioned is running here. So if you want to find out on what IP this service is running, you can basically do a dig. Is it readable? Yeah, okay. Do a dig to Postgres main master.service.madme, and basically you will get back an IP address, and basically tells you the IP address where this service is running. So fairly easy, very easy. But yes, from a service discovery endpoint service, I would expect that I only get endpoints that are currently up and running, just the same way as Kubernetes does it, using health checks. So Consul also has some health check capabilities. It has a lot more health check types than Kubernetes is, because you are basically running on a VM. So except for TCP or UDP or HTTP or gRPC, you can also define health checks for Docker services. You can check if there is a certain Docker image running. You can check if there is a systemd service is running. You can even run custom scripts. And there is this nice TTL type of health check where it opens an HTTP endpoint, which you have to periodically send a request to for the service to respond that if it's being alive or not. And yeah, so on the right side you will see a modified service definition where you can simply create this service check, and you can have multiple service checks, not just a single one. So it's quite cool. Okay, yeah. So, but this is cool. We have console running, but we also needed to somehow make sure that we can discover these services running on this .madme domain from inside the Kubernetes cluster. So what we did, we had to do some certain modifications to our configuration, to our DNS configuration on the console cluster. So probably most of you, it's not necessarily a requirement, but hopefully most of you are using also a node local DNS in your Kubernetes cluster, which role is basically to cache DNS queries just to offload a little bit the core DNS endpoint. So what we basically did, we modified the config map of this deployment, and we included the .madme, configuration domain, and we set this endpoint to forward the request to the 10.33.16.39, whatever IP, where basically the console DNS endpoint is running. So this way, at this point, we were able to discover domain names running on .madme domain. And yeah, and for everything else, we still queried core DNS running in Kubernetes, or we queried the upstream DNS, which was configured by the ACP. Okay, so at this point, we could resolve domains from the console cluster from Kubernetes, and we wanted to be able to do the same on our VM environment as well. So where we just simply edited the network manager, and we enabled the DNS mask process, which is also a local DNS cache basically, and we added an entry point for the .madme domain. And for this domain, the requests are forwarded to the console agent running locally on port 8600. This is the default DNS endpoint port for console. So basically, this way we were now able to discover these domains without doing any further modifications. And yeah, so we also wanted to able to discover services on VMs that were running inside the Kubernetes cluster. And for that, there is this nice tool called K8SSync. It's also from HashiCorp. And you can install this small piece of software alongside the console installation. And what it does, it basically synchronizes all your service definitions inside the Kubernetes cluster and exposes them to console, so they become available. These services, as you can see on the console UI, are not editable. You cannot edit it. And they have a tag KDS, and it says that it's registered via Kubernetes. So if you try to resolve a domain name, for instance, here I'm trying to resolve the IP address of the ingress controller, which is exposed internally on the load balancer, it will basically return the IP address of the load balancer where the service is running. Okay, so at this point, yes, we were able to discover all the services running inside Kubernetes, outside Kubernetes, and we interconnected these two worlds using console, and we were able to resolve those domains from inside pods and from a VM as well. So I'm going to do a really quick demo on how do health checks work. Let me show you quickly this endpoint. So yeah, so these are basically the services that are exposed from the Kubernetes towards the console. And let me try Promptail. Promptail is a little log gathering service. I hope most of you probably know it. So if you want to find out where Promptail is running on which VMs, you can do a dig promptail.service.madme. Service.madme. It returns me the list of the VMs where the service is running. So as I mentioned, this service also has a health check configured. I'm currently running on 172.180.9, which is included in this list. So if I stop this service for a while, I will see that within a few seconds, the health check will fail. This information will get propagated with this gossip protocol, and I'll immediately notice that there is something wrong, that this service is down. So if I try to query this endpoint again, that IP address won't be present anymore. So the DNS endpoint is automatically updated, and and yes, as you can see, the TTL on these responses are set to 0. So your clients, your local DNS cache won't be caching those entries. So a nice cool feature is that you can also, of course, request SRV records. And the SRV records won't return you just an IP address, but it also returns you the port where it is basically running. And you can also specify weights and priorities for the SRV records. So just by using console, you can enable a very easy, very simple load balancing mechanism just on the DNS level without having to deploy any kind of fancy AJ proxy or whatever you'd use as a load balancer. Okay, yeah, let me start Promptail here because I will be getting notifications. Yeah, so if I start in a few seconds, it just comes back alive and everything goes back to normal. Yeah, there you go. Okay, so at the next point, we wanted to, so since we were migrating away from VMs to Kubernetes, we already had an ingress controller, so ingress controller deployed on a Kubernetes cluster, and we wanted to be able to target some services running on VMs through this ingress controller. Because yeah, we wanted to get rid of the application layer gateways. Why would we use them if we don't really use them anymore, if we eventually migrate to Kubernetes anyways? So I previously mentioned that this KDS sync is synchronizing services from the Kubernetes cluster into console, but it does it the other way around as well. So I'm going to show this is going to be more understandable. So in this situation, the KDS syncs basically picks up all the services that are registered by the agents. It creates a service definition into Kubernetes, and all you have to do is it's enough if you just create basically an ingress manifest for this service, and this way you can achieve a very easy reverse proxy mechanism using the ingress controller. So basically what happens if a request is coming in from outside through a public IP to your ingress, it will get proxied. The request gets proxied to the service running on a VM, not inside the Kubernetes cluster. And yeah, one little side note, this service that is imported using KZS sync is marked as type external name. So, and yes, since console itself has service checks built in, you don't have to care about any health and any service checks, any health checks in Kubernetes. So this domain will take care of that you will always be directed to an endpoint that is always open and live. Okay, next cool feature. We previously were monitoring our Kubernetes, our virtual machine-based environment with the same Grafana, Prometheus, and Alert Manager stack. And eventually we deployed this Prometheus stack on Kubernetes as well. So we wanted to get rid of the old VM deployment. And yeah, we were looking into mechanism, how can we basically include those targets that were running on the VMs as well. And since we have console, we hoped that it somehow would be possible. And luckily, Prometheus has a console plugin. But basically what it does, we added this scrape config into the Prometheus configuration, where you have to define the server name, where the console cluster is running, and you have to specify which data center to pull. And we also defined a tag matrix. So basically what it does, it pulls out all the services that are running in console, and will filter out those services that have a tag set to metrics. And if it found any of those services, it included those as a scrape target and start scraping those endpoints. Yeah, very easy. This is how it looks like. Yes, so if I go back to my service catalog, and now I search for services that have the tag metrics, you see that these are the endpoints basically, which are marked as metrics. They have a tag metric, and we are storing some information in the metadata. And with Prometheus, we can, if you open the service discovery page, you see all the endpoints that are discovered, and we can see that we have this console scrape config set here. And basically, these are the endpoints that were discovered using the console endpoint. And with some reliable configs, we made sure that the labels are right, so we can use the standard Grafana dashboards that are basically built in with the Prometheus operator, the Prometheus stack. So if I open for instance, the page for the Grafana dashboard for node exporters, I can immediately see that all my VMs basically got included in those metrics. Yeah, okay, so that's about monitoring. So basically, at this point, we were more or less able to migrate every supporting services into Kubernetes. So we were quite happy. And yes, there are still some deployments at the moment which are where the migration is ongoing. But yes, we have already a few customers running fully in Kubernetes now. So we are quite happy with the results. And as my last slide, I would like to talk about some additional feature that Consul has, but we don't necessarily use by ourselves. So additionally, Consul also provides a distributed key value store. We use the key value store, for instance, to store Ansible inventories. So we have a dynamic Python script that basically pulls this inventory every time we run Terraform. So the dynamic inventory is generated with Terraform. So when we do changes into Terraform, they get automatically reflected into the key value store, and then we can pull that and run Ansible based on this environment, based on this inventory. It also has a distributed locking mechanism. It can be a backend for many HashiCorp solutions like Vault, Nomad, or Terraform. At the same time, it also provides a full service mesh. We don't use that, but it's really cool. It can inject Envoy sidecars to your workloads and creates MTLS-based encrypted connections. It has a gateway capability using which you can interconnect multiple Kubernetes into each other and use the Envoy the same way, basically to establish connections between workloads running in the different environments. And the last piece of software I really like, this is called Consul template plus Consul KV sync. Consul KV sync is a very small piece of software that can pull your Git repository, synchronize the content of your repository into Consul key value store. And the Consul template basically is a small little daemon that connects to your key value store or your HashiCorp Vault. And it is watching changes, if there are any changes to this key value store. And if there is a change, it is going to render a template, and it can run a script or whatever you want it to run it. And so it could be a very nice use case if you want to trigger, for instance, if you want to trigger config rebuild and re-rendering for certain applications like nginx. So it can be a very nice automation tool if you are still running some workloads in a VM world. Okay, so quick summary. I don't think it's really important now, and that would be it. So thank you.
Perfect. Thank you very much. So far, we haven't got any questions. So if you have any questions for the speaker, please use the Slido. Going once, going twice. If that's the case, you can always find the speaker after the talk and talk in person. That's always an option. I thank you very much for your presentation. Now we will be continuing in 10 minutes at 15:40 with the lightning talks. Thank you.
Cybersecurity is an infinite battlefield.
The bad guys are getting slicker,
Stealthier.
Engineering their own super weapons.
We can get lost in that darkness, in what we are all against.
Or we can focus on what we're all here for.
People.
Congratulations.
Oh my God.
Each other.
For our neighbors,
Our kids.
People with an I or T in their job titles.
For new leaders dragging century-old giants into the future.
For wild thinkers.
Designated warriors.
For the people they protect.
We're never going to get old, are we, Grandma?
I'm not.
People with passwords like password 123 exclamation point.
For people who trusted strangers and lost everything.
For titans of industry.
titans of taco trucks.
Titans with toddlers.
For people.
For each other.
We can focus on the fear.
Or we can keep reminding ourselves
What security is really about.
As containers and modern databases get widely adopted and enter production, all data needs to be secured and protected. A backup strategy is a major component of this plan. Without a comprehensive data protection plan, malicious actors can take hold of your mission-critical Kubernetes data, and you won't have a way to fully recover. Someone who can back up and restore complex Kubernetes data, configurations, and objects, and ensure business continuity. With Portworx Backup, you can save the day. Portworx Backup offers full-service, app-aware, and container-granular data protection with ransomware protection, disaster recovery, and application migration to any environment. This helps you securely restore data with a single click. Portworx Backup, the easy button to protect your Kubernetes workload.
Hello. Hi, welcome everybody. We continue with the lightning talks, and our first speaker is Pavel Strobl, and he will be talking about how to monitor Prusa 3D printers with Grafana and Prometheus. It's all yours.
Okay, thank you. Good afternoon. I'm here to tell you about how I created a Prometheus exporter for Prusa printers. Yeah. My name is Pavel Strobel, and I work at Prusa Research as DevOps engineer. My main goal is to make sure that our web services like printables, eShop knowledge base, or others works as they should. And I'm in charge, as you can tell, of observability. Also, I'm in charge of infrastructure, and I try to not destroy our cluster in our cluster. Of course, I work with Grafana and Prometheus, and I make pretty dashboards with Qt panels. Instead of that, I enjoy hardware devices. I made like few of them for another company, but let's say it's a long time ago when I made one. I like cars, driving them, going for track days, and also I can make my own beer in the future even with monitoring. Okay, what is Prometheus Exporter? Prometheus first. Prometheus is a tool for collecting data metrics, and you want to store these data effectively. There is a few ways how to do that. Prometheus is one kind of solution, not only, of course, only one. And Exporter is something that provides the data for Prometheus to scrape. It uses pool models, so there is no much overhead for devices, and that was my goal. You can expose metrics on any device, even something like ESP32 or Raspberry Pi Pico, which is not that powerful to handle much more than that it needs. Why? I have multiple printers in my living room. My wife also has a 3D printer, so I wanted to get the data from all of them, from my and hers. So I chose to create a Prometheus exporter for scraping data from these printers. It uses Prusa Link API, so it's public, and you can use it also. And why not visualize these data in Grafana or alert some issues like faulty MMU? Okay. You can also create your own dashboards and probably use even machine learning with technologies like Tamland by GitLab. Okay, how it works? It just works. Somehow, I guess. I used Golang for implementation because it's a common language in Prometheus landscape. It's my first project in Golang, so it looks like that. And I've never been a great programmer, but I can write line or two, maybe three. I used Prometheus library and implemented 3 handlers for different type boards and frameworks that Prusa uses. Unfortunately, right now I support only FDM printers, not the study ones. Okay, it's demo time. Okay, this is one dashboard that is used for overview of every printer I have at home. This is body dashboard, which is used for MK4, MK, and Mini. And I have also for Einstein that is used for MK3 and legacy one that will be dropped and deprecated. Okay, sorry, I don't have much time. Okay, current status. Well, it works, but it's a little bit messy, let's say, and I don't have that much time to improve my code, but I would like to improve it. I want to log data from printers to Glocky, get images from cameras to Grafana, and much more. Okay, thanks. I was able to get it in 5 minutes, and If you need anything, you can scan this QR code, which is my repository with this talk, and see you later.
Thank you very much. Our next talk is Jakub Zikl with Devs and SREs from frenemies to mates.
All right. Well, this lightning talk serves as a heads up on the significance of not just getting along, but also embracing cooperation and knowledge exchange within our teams. Why? Not so long ago, I witnessed a team of developers who seemed indifferent about their code. They simply pushed their changes to the GitLab and paid no attention to the consequences which occurred. Whether it was on Friday night or Monday morning, the aftermath landed on the shoulders of the SRE or Ops team. Well, the Ops team had to be on call, tirelessly debugging and hotfixing the bugs which were created by the developers. While this may seem like an easy life for us developers, it doesn't contribute to better collaboration among team members. Why is it important to foster cooperation? Well, when the application doesn't behave as expected, it's easy to engage into the blame game. However, when developers lack understanding of what happens behind the scenes, and the Ops team has no insight into how the application actually works, it takes longer to resolve issues and may lead to unfortunate consequences resulting from misinformed choices. How can we address this challenge? If we take a step back, both sides are actually trying to achieve the same goal. While allowing developers to access clusters might seem risky, it's a risk worth taking. By doing so, you reduce the potential damage that developers may cause. As developers understand your craft, they might even bring fresh ideas to the tools you use, and it might shape those tools in the future. By helping developers understand the platform and operations, they, in turn, can help you better understand the application. It becomes a mutually beneficial exchange, leading to improved outcomes. Moreover, this collab journey not only enhances your knowledge, but can also foster meaningful friendships, resulting in even better results. In conclusion, it's crucial to move beyond merely getting along and emphasize the significance of cooperation and knowledge exchange within teams. By breaking down walls between developers and the Ops team, we enable a deeper understanding of each other's roles and responsibilities. So, let's embrace this mindset, bridge the gaps, and create a culture of collaboration and shared knowledge. Thank you.
Thank you very much. We have some time. And the next talk will be eBPF Verifier, What's Turing Completeness by Milan Plžík.
neznie dobře, lebo ja... Nie, bude to fungovať. Okay. Okay.
Okay, so hello everyone. We can start a countdown. The clock is not running yet.
That's fine.
Never mind. Okay, good for me. So there was a lot of chat about eBPF during various talks here around. So I thought, since we're on the academic ground here, it might be interesting to have a look at eBPF verifier and what in the world actually the Turing completeness is. Because there was a chat about what everything the eBPF can, because it's running in a kernel, it can hook into various kernel parts of the kernel, and do interesting things with network packets, memory, so on and so forth. So, what in the world, and especially, how does it not break the kernel, since we mere mortals are now essentially running a kernel space code? So, broken kernel code usually means kernel panic, or worse, some kind of security incidents, which we probably don't want to afford that easily. And this usually happens if we load a kernel module that's not exactly okay-ish in the kernel. So possible breakage is usually by reading arbitrary memory, writing arbitrary memory, or getting stuck in an infinite loop. As for what is verifier, so you probably heard that eBPF compiles into bytecode that turns into native instructions inside the kernel. But before the actual compilation into native code, there's a verifier that checks the code by the means of static analysis mostly. So the bytecode is fairly high level and understands type of data stored in variables, and only strict subset of programs is allowed to run. Type checks that are done on the bytecode are basically, so the bytecode understands types. So there are a few basic memory types, for instance, uninitialized memory. So if someone tries to read uninitialized memory, the verifier will figure it out and forbid the program from being loaded. There's a scalar variable, few interesting pointer types that allow us to prevent from accessing memory that shouldn't be accessed otherwise. So by the means of static analysis, there's a pretty good chance that the verifier can figure out what's being broke, that something is being weird and not allow the program to run. Then there's that interesting thing that's called halting problem, that's more from formal languages and automatons, and I'll run through very quickly. So this is basically a problem about deciding whether a program stops or not. So in computability theory, there are a few classes of machines that we can run programs on. It's finite state automata, push-down automata, and Turing machines, and few other exotic ones that we won't get into at all. So what can we say about halting problems on these machines? So firstly, while one is obviously a program that won't halt that easily. All the machines basically speak about what exactly are the instructions that we are allowed to run and what exactly can we do to can the program compute. So deterministic finite state automatons in a nutshell and really quick. So it's fairly simple device that basically has some kind of finite state and it processes some inputs, basically some symbols that are coming to its input. Each step means processing a single input, a single character from an input. And if there's a rule in the program, which is in here, the program will proceed to the next step. If the program processes the whole input and in some terminal state, then everything is fine and the program has finished. So if we're only allowed to code such programs, we're fine. We know that these programs finish because at each single step it either processes a letter from an input or halts or basically can't proceed anymore. But these are fairly simple programs that won't allow to do us too much on eBPF. Also, it would do some interesting things. Then there are some more complex ones, as deterministic push-down automatons. These can also be determined to be stopped or whether they are terminating or not. And then there's deterministic Turing state machines, which are a complete monster that's actually running. That's actually something that can be simulated on a CPU. Well, it's akin to CPU, and we can't decide where these programs stop. So what about eBPF? eBPF is able to prevent infinite loops in the eBPF programs. Well, kernel eBPF VM is able to prevent these loops because it does static analysis of the whole programs and tries to avoid any kind of situations where there would be an infinite loop. Originally, loops weren't even allowed, and everything had to be unrolled to a sequence of instructions. Now there are some allowed bounded loops. And that's it. For more information, there's the talk. This is something I studied for a few minutes today and thought it would be an interesting thing to share.
Thank you very much. Our next lightning talk is titled Kubernetes at Home, Self-Hosting Lesson. Vadim Rudkovsky.
Yeah.
Oh, can I show this on this one?
Yeah, okay.
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 Perfect. Yeah, we can start, I guess. Hello. My name is Vadim Rudkovsky. I work for Red Hat on day job hacking on OpenShift, and during the rest of the day, I run Kubernetes at home. You may want to ask, why would you want to do the same? Why would you even want to run something at home as an additional machine? The main concern is usually the privacy, because you don't want some of your data to be read by Google or other companies. The examples would be precious moments with your family and photos and things like that. Then you may want to run an entire Nextcloud suite, which allows you to give your own private file storage, calendar, your own local mail and additional things to integrate with that. And another example might be Linux ISOs in HD quality, totally legal. And anything your heart desires. Some folks run experiments on their cloud. I heard of Kafka streams being run at home. I experiment with Kubernetes just to try out new patches and things like that. An important note why you would not want to self-host. You are now officially becoming an SRE with 24/7 on call, getting messages from your family that something is broken and you need to immediately fix it. So you know that's pretty serious. Why would you want to pick Kubernetes to be running at home? The benefits are that it's declarative, meaning you don't have to work with a bunch of bash scripts and things. You mostly work with YAML, and it's already been stored. If you use GitOps, then you will get much more benefits. Of course, it's much harder to start, but the ease of use outweighs that in the long run. An additional significant benefit is that you get to learn a lot from your live experience. If you're not working with customers directly and so on, you learn what kind of issues you hit when you're running Kubernetes. Few significant tricks to do. I would recommend to use K3s distribution, mostly because it's optimized to be used on slow disks, meaning it doesn't use etcd, which requires a high-speed disk, but it uses SQLite, so you can even run this on slow SSD or even HDD. I would not recommend to use Raspberry Pis as your own single node because they are known to be fairly slow. They are maybe a good fit for your storage nodes to share with NFS and so on, but it's not recommended to run as a production cluster. Ideal nodes for the Kubernetes at home would be NUC-style devices, the small fanless computers, or the laptops, because they are optimized to be minimal, rather silent, but you must be aware that you have to take out the battery, otherwise it's a fire security hazard. Next lesson is GitOps will save you a lot of time for the maintenance. It's rather hard to describe, but it really showcases how Kubernetes can be descriptive, declarative, and very easy to use. Next, few clouds offer free tiers. Google, Amazon, all of them have them. You may want to use them as their storage. Also, very popular is combining different things, like you don't have to host S3 at home. You can use Amazon's one. It would be much cheaper, and so on. If you may want to expose your server externally, there are a few solutions. One of them is setting up a VPN with WireGuard, but probably the easiest one would be Cloudflare tunnels, which allows you to expose your own internal network to the internet, but you must be aware that it will slow down your home internet, and it's incredibly risky from the security standpoint, so you must understand what you're doing. Few helpful links would be an awesome self-hosted links repository on GitHub. It shows a lot of examples how to run applications, which applications are filling, what are their differences, and so on and so forth. It's a huge list, so you may find something useful for yourself. Next, there is a repository called Kubernetes at Home. It's specifically targeting GitOps plus Helm charts, so it already gives you actual users Helm charts, how they are configuring it, what are the use cases they are filling in, so on and so forth. So it's incredibly helpful to get started. And that's pretty much it.
Perfectly on time. Thank you. Our next talk is, wow, what the heck is Kubernetes multi-tenancy? And our speaker is Dario Trancitella. Sorry, can you reintroduce yourself then?
Sorry?
Can you reintroduce yourself so that...
Dario Tranchitella. Yeah, doesn't matter. Dario is enough. Honestly, I hope it works. And I'm going to talk about Dune. No, I'm just joking, but it's mirror, it doesn't work. Oh, it's working, yes. Okay. I can start the timer? Go for it. Yeah. So, hello, everybody. My name is Dario, and I'm going to talk about multi-tenancy. So, what the heck is multi-tenancy? So, essentially, it's an architecture where you're using a shared infrastructure to serve multiple tenants. So the example is obviously the building where you got multiple tenants, so people that is renting several apartments. So why would you like to implement multi-tenancy on Kubernetes? Essentially because you want to optimize the resources and also optimize the cost of your Kubernetes cluster, and also to enhance the governance, because when you're using, when you have multiple tenants, so multiple users using your shared infrastructure, you could have issues from the security standpoint. So let's try to understand how can I achieve multi-tenancy on Kubernetes. Essentially, what we have to do is to identify the users. So we need to understand if these users are humans, so people with a token or certificate identifying the users, or rather identifying also service accounts, because if you think about that, the service accounts in Kubernetes, essentially, they are regular users. And then we have to identify the resources in a Kubernetes cluster. So we can think about the Kubernetes resources like storage class, ingress classes, namespaces, pods, and so on and so forth. But we have also some boundaries that are cluster scope. You can think about the nodes or the volumes or the ingress class, the storage class, and also the OS resources like CPU and memory. So keep in mind that right now Kubernetes allows to implement a sort of soft multi-tenancy, and that's the namespace, essentially, because with the namespace, what we are going to do is to create a sort of slice of your cluster, and in your namespace, you can create your pods, deployments, and all other resources. But unfortunately, it doesn't work from the concept of tenancy, because when you talk about multi-tenancy, especially from the application development, you think about multiple instances. So you don't have a single instance like the namespace. And unfortunately, in Kubernetes, the concept of tenant doesn't exist. But we got all the primitives, so all the resources that we can use to create a multi-tenant environment. And which are these ones? So from the resource control, that is pretty important, because obviously you have to tame the governance of your cluster. You can use the resource quota and the limit range. Resource quota is an API that allows you to set the amount of CPU and memory you can consume in your namespace. And with the limit range, what you're going to do is to set default values and minimum and maximum values for the CPU and memory and so on and so forth. Because obviously, you can run pods without any resource attached to it, and these pods are going to consume all the resources of the node. So you don't want to get that in a shared environment. You have to create boundaries. And then we have to talk about resource isolation. So we can talk about namespaces. Well, everybody knows namespaces. But you have also to isolate the network through network policies and also prevent privilege escalations. So you have to implement pod security standards or pod security policies, although deprecated. And then obviously you have to implement the RBAC, because otherwise I can start a privilege escalation from the application standpoint, so I can connect to the API server, getting all the nodes, information, sensitive data, and blah, blah, blah. And obviously what you can do is also to isolate the workloads on specific nodes. So you can use a feature introduced by, I don't remember the version of Kubernetes, that allows you to place all the workloads of a specific namespace on a set of node pool. So we have all the primitives here, but there is a problem because we don't have the concept of tenant. And that's the reason I would like to present to you a project, my first open source project, honestly, that its name is Capsule. So essentially with Capsule, we introduce a concept, a new CRD that is named tenant, that allows to collect namespaces together. And the architecture is pretty simple because it's an operator, so you can install on any Kubernetes cluster. We are not reinventing the wheel. And essentially, we are grouping together namespaces and using a policy engine that is built in Capsule. You can set your own policies, so you can enforce resource quota at the tenant level rather than the namespace level. So how it works. Essentially, we are using all the machinery offered by Kubernetes. So we are identifying the users. So it works with certificates or tokens. And then we are using the webhooks, so the dynamic admission controllers. We are mutating some calls, and we are validating some requests. So can I get all the pods in this namespace? No, you cannot. Or can I create this pod running on untrusted images? Yes, you can, or no, you cannot. And then we are using the owner reference. So the owner reference is the way to create a sort of connection between objects in Kubernetes. Essentially, with the owner reference, you can say this namespace belongs to another resource. So we are able to create a system, a hierarchy between the owner and the child elements, so the tenant and the namespaces. And then finally, we are using the CRDs. So CRDs is a way to extend the Kubernetes API server. We implemented several CRDs, and I think that I'm running out of time. So I try to be as quick as possible, but we are not breaking any user experience, and everything is open source. You can check out on GitHub, and that's all.
Thank you very much. Our next talk seems to be in Czech. It's titled Nepište shell skripty, použij Go. And unfortunately, I cannot decipher the name, so I will not even try. So whoever signed up for this talk, please calm down.
Tak jo, ahoj, já vás tu vítám. Já jsem zrecykloval jeden starší talk z jiné konference, ale myslím si, že byl dobrý, protože je to v češtině. Mám všechny slajdy v češtině. Já jsem Ondra Šika, jsem DevOpsák, zabývám se tím, že školím, konzultuju, vlastně motám se kolem DevOps. A v zásadě dneska bych chtěl říkat, proč nechcem psát skripty a tooly v Shellu, ale v Goučku. Tak, proč to vlastně chceme dělat? Tak za prvý chceme si zjednodušit práci. Všichni jsme líní, chceme prostě opakující tásky neřešit pořád poznovu, ale chceme si to nějakým způsobem zjednodušit. Tak, kde to chceme použít? Můžeme generovat kódy, můžeme pracovat s Kubernetem, můžeme mít skripty na testování, v zásadě cokoliv, kde potřebujeme dělat něco opakovaně. Tak. A jo, to řešení, shell skripty, fungují dobře, no, možná ne. A vlastně shell skripty napíšeme jednou, pořád je pouštíme, to je super. Shell máme taky všude, to OK. Jednoduše se píšou, máme nějaký repo s těma shell skriptama a takže vlastně shell skripty jsou fajn. No, ono to tak úplně není. Všude máme bash, všude máme shell, nebo pokud chceme psát v PostgreSQL shellu, to je hrozný, máme opravdu všude bash, co když jsme na Windowsech a najednou jako problém. Opravdu se píšou tak jednoduše, jak jako si myslíme, tak pokud shell script znamená 10 řádků, 10 příkazů pod sebou, tak jo. Pokud tam máme dělat něco složitějšího, jako je práce s nějakýma datama, tak už úplně ne. Distribuce těch shell scriptů, pokud nemůžeme použít Git, typicky nějaký velmi izolovaný prostředí, no nic moc. A to samý bez internetu ještě horší. Tak, a to řešení samozřejmě nějaký je. Můžeme psát ty skripty v Pythonu, ale to nám vlastně přinese jedno zlepšení a zase všechno ostatní bude horší. To zlepšení je v tom, že se to píše líp než ten bash. Můžeme mít hromadu Python knihoven, to je super, ale na druhou stranu Python se možná pouští ještě hůř než ten bash nebo než ten shell, protože ne všude máme Python, ne všude máme Python knihovny, musíme je stahovat, není to úplně nejrychlejší. Distribuce toho je hrozná a potřebujeme na to nějakou závislost, to je ten Python a potřebujeme mít ty knihovny, což je zase jako další věc. Jak se to distribuuje? No, pořád to není jedna binárka. Tak, takže jedno řešení. Můžeme použít Perl, ale ten je horší jak na psaní, tak na pouštění, a nebo použijeme Goučko. Tak, a proč Goučko? V Goučku distribuujeme staticky linkované binárky, což je výhoda, že vlastně nemusíme stahovat nic jiného, kromě naší binárky. Naše binárka v sobě má zakompilováno úplně všechno. Goučko je poměrně jednoduchý jazyk, takže i ty, co v Goučku nevyvíjejí, tak se ho naučí velmi rychle, nebo si osvojí to, co potřebují, velmi rychle. Skvěle se to distribuuje a můžeme to zabalit do brew, že je to jedna binárka, takže je to jako super jednoduchý. A v tom Goučku je na to skvělý tooling. Ať už právě ta distribuce pomocí Go releaseru nebo psaní těch CLI, Cobra Viper nám to velmi, velmi usnadní. Tak, statické linkované binárky, co to je? Je to binárka, která nemá žádné závislosti. To znamená, je to executable, který pustíte sám o sobě. Potřebujete akorát kernel a tu vaši binárku. V Goučku se to spustí nebo zbuildí velmi jednoduše, prostě vypnete si GO a máte to. Takže udělat statickou linkovanou binárku v Goučku super jednoduchý, ve všem ostatním zase tak jednoduchý to není. Potřebujeme teda mít správnou binárku pro každou platformu, ať už je to teda Windows, Linux, Mac a potom správnou architekturu, čili jestli to je AMDčko nebo ARM. Go releaser nám umožní velmi jednoduše distribuovat ty binárky. V zásadě Go releaser nám zbuildí všechny binárky, všechny optiony, ty buildy nám pušne do GitHubu, takže v GitHubu je máme v releasech, zároveň nám vytvoří bavičky pro brew, bavičky pro scoop, což je Windows Package Manager, a celá ta distribuce toho softwaru je potom výrazně jednodušší. Potom samozřejmě distribuce binárek, brew install, na Linuxu bohužel curl a nějaký instalační skript, což je de facto wget a rozbalení. Na Windowsu winget a scoop, takže ta instalace těch našich toolů je potom všude jako jednoduchá. Ještě jsem to nezmínil, Goučko je multiplatformní, to znamená, že to zbuildím jednou a mám to teda, funguje mi to na Windowsech, funguje mi to na Linuxu, na Macu, super. Tak, ty knihovny, které tam použijem, Cobra a Viper. Cobra je knihovna na práci s CVčkem, tu knihovnu využívá například Kubernetes, Argo, v zásadě všechny moderní CVčka, takže Kubernetes klient má tu Cobru taky použitou. Je to super jednoduchý na používání, super příjemný, generuje vám to dokumentaci, generuje vám to helpy, má to autocomplete, všechno je to z krabice, takže nemusíte znovu vymýšlet kolo. Viper je potom na práci s konfigurákama, takže když ty vaše utilitky potřebují někde nějaké konfigurace, uložit si state, uložit si nějaké přihlašování, tak zase můžete velmi jednoduše pracovat s JSONama, s YAMLama, s bizarnostmi jako toml a načítat věci z environment proměnných. Tak. Funguje tam ten completion by default, to znamená, veškeré vaše tooly budou mít z krabice velmi skvělý autocomplete pro Z-Shell, Bash, ale třeba i pro PowerShell na Windowsech. Vygenerujete z toho dokumentaci, vypadne z toho normálně readmíčko pro GitHub, nebo nejenom readmíčko, ale pro každý příkaz vypadne prostě stránka s nějakým manuálem. Zase to asi se dostanete v tom CVčku, ale jste to schopni prostě pustit na GitHubu, jste to schopni pustit jako hodit víceméně všude. Tak. A tady vám chci ukázat nějaký moje CVčka, který jsem vytvořil, nebo který pořád jako si tvořím. To první je SLU, což je Cyclops Utils, je to zase nějaké firemní utilitky. Koukám, že už jsem přešel čas, takže se omlouvám. Já to zrychlím, vezmu jenom to SLU, takže tady když tak link, kdybyste se chtěli podívat. A je to právě ta náhrada do těch našich shell skriptů. Máme tam věci na práci s Argem, máme tam věci na práci s TLSkem, takže když chci vyparsovat TLSku jednoduše, takhle SLU se parse, další věci, potřebuji někde generovat logy pro nějaké testování, náhodný generátor logů, potřebuji klíček VPNC, všechno to máme vevnitř. Je to jedna binárka, kterou distribuujeme, žádné skripty, ale jedna věc, zbytek můžu přeskákat, shrnutí. Je to výrazně jednodušší, jak na vývoj, tak na používání, než hromadu shell skriptů. Goučko, píše se skvěle, distribuuje se skvěle, je to super. Takže díky za pozornost a jestli jsou nějaké dotazy, tak ptejte se.
Thank you very much. I didn't cut you off because you are the last speaker, and it was really interesting, so that was...
Okay.